All right, let me make sure I got all the stuff that doesn't need to run shut down real quick. Close that. All right, that should be good. All right, my name is Mike. Today's 2D CAD 2-axis day. So we'll be drawing up a 2D part, maybe a couple 2D parts. We'll play it by ear. And then this afternoon, or maybe I think what we'll do is we'll draw a part, we'll do some cam. And then this afternoon, we'll draw another part, we'll do some more cam. For those of you that want to be here for a shorter amount of time. So you won't have to stay all day to get to that cam section. We'll do some of that by about 11 o'clock Eastern times where we're at. So it's 10 now. All right, so we're going to start off by drawing out this part. Now, I don't have a print to give you guys. This was one that I haven't had a chance to turn into a print yet. It's just kind of a funky little part I've been messing around with. And all very basic drawing techniques, but we're going to go through doing layers and pretty much take care of everything. So if you guys have questions that pop up at any point throughout this, there should be a questions box on your screen. You could just click in there, and it doesn't have to be a question. If you just want to make a comment, that's fine as well. Throw it in there. And then, like I said, if you guys have anything specific you want to see, let me know. I want to make sure you guys get the most out of this as possible. And honestly, at this point, we've been doing these things so long, I'm starting to run out of things to talk about. So I need some inspiration from you guys as time goes on. Like I said, if you have any cool part files, and this is for any case, you can send them to me and I will use them. If you're cool with me using them during one of these to see how we would go about programming something, or if you have a print and you want to see how we might go about drawing it, make sure it's cool with whoever has the print. We could definitely plan for something like that. And you guys can email me stuff like that. You could just email it to training@bobcad.com and put in the subject just, hey, here's a possible idea for a live event. And I'd love to use some of your guys' real parts, because some of the parts we make aren't really as realistic as you guys might want. So, all right, let's get into this. So as of now, the only thing I really know for this drawing, I know all of it, but the big things that I need to know are really the hole sizes for everything. So we have an outer arc. We have an inner arc that makes this slot. We have a 1 inch, so it's a 1 inch inside hole here. And then this inside lip to this slot is going to be a 3 inch diameter arc. Then we have a 4.5 inch diameter arc. And then we have a 6 inch diameter arc. So I'm just going to open up a new window here. And I'm just going to start with the arc command. Arcs are, as straightforward as they can be. So I'm going to start with the outside arc. So I'm going to make a 6 inch diameter arc and hit OK. And then I'm going to start with the inside, and I'm going to do the inside arc. And that way I can go ahead and put these two on their own layer. So this is just going to be kind of the base of everything. This is the kind of outer shell. So I'm just going to call it base. That makes sense. And then we're going to make a new layer. The next two arcs that we're going to create are what we're going to use to create those slots that we have in the part. So I'm just going to name this layer slots. Whoops. Slots. There we go. I had the caps on. So we're going to do slots. Now these ones are going to be a diameter of 3 inches. And if you're using 33, if you're still running version 33 or under, you guys don't have the diameter section. That's new to version 34. So you'll just have to make sure you enter 3 and then divide it by 2. That's the easiest way to get your radius. Just type in your diameter, divide it by 2. All the boxes are calculators, so it'll do the math for you. And then you'll have the right values. And then I'm just going to go ahead and hit OK. So that's my 3 inch arc. And then we have our diameter at 4.5 for the outer part of that slot. So I'm going to go ahead and hit OK. So then we have our layers over here. Now we can turn these on and off as needed. And that's just helpful, not only right now, but because we're not turning this into a solid model, it'll help me a lot later when we do our cam as well. So I want to add one more arc to this. I just need to add a new layer for it. It's going to be a counter bore, and it's just going to go right around the inside there. So I'll just add a new layer. We'll call this C-bore. And this one is just going to be a 1.25 arc. So 1.25 diameter right there. So that's just going to be kind of we'll call it like a bearing race or something like that. Well, not really erase, I guess. So we have our counter bore there. We're just going to make sure it's centered on XYZ 0 and hit OK. And then I want to make sure to go back to my slot layer for the next part, because now is where we're actually going to define the angle of those slots the way we did. So the way I do this, and there's multiple ways that you could do this. I'll do it kind of both ways. So I'm first going to start with a line that goes straight out along the X on the 3 o'clock position here. So it's along the X, so the direction is 0 degrees. And I'm just going to make the length long enough to pass that line. Any extra is fine. We're going to trim it off later on anyway, so it's not a big deal. So this line is going to start by going to 0. And you could go right to your angle with this using this angle button, but I'm going to put this one down first. So there's my first line. And then if we wanted to, I want a 45-degree slot. So I could say 45 degrees on the angle. Now that whole width right there would be the full slot. And I could use it like this, or what I can do is divide that number by 2. So I'm only going half up, and then I'm going to go the other half down. So I can go ahead and hit OK, and I'll put that one in. And then all I have to do is change this number to a negative. And the reason I do this way, instead of just going with the 45 and trimming things out, which I could do, it's just so I have everything clocked at my kind of 3 o'clock position. Now, I could also just do it to 45 and then rotate it 22.5 degrees or negative 22.5. And that would work as well to clock me back at my 0. But if I'm already drawing it and it's so simple to do, it's really not that difficult. You could also take just this singular line here and rotate that 22.5 degrees up, 22.5 degrees down, and you wouldn't even have to use the line command to do any of that stuff. So there's a bunch of ways to skin this cat. It's just how do you want to do it? So I'm going to go ahead and hit OK and then cancel out. From here, I'm just going to trim out all the excess geometry that I no longer need. So I can go to Utilities and then Quick Trim. Now, for those of you guys that are new, if this is one of your first classes, I'm looking at this list. A lot of you guys aren't new. I've talked to many of you before. So for those of you that are new to the system, the name of the tab really defines the tab. The Create 2D tab is where you're going to find all the functions you need to create 2D geometry. The important word being create. All right. The Create 3D tab is about creating 3D geometry, whether it's solids or just surfaces or extrusions or fillets. It's all going to be found on there, and you're creating the geometry. Now, the Utilities tab is where it gets a little different, because the Utilities tab, every feature on here needs a piece of geometry before it has any. You're not creating with this tab, I guess is the best way to say it. When you go to translate something, if that something doesn't exist, you can't translate it. And it's the same for most of these features. So whenever you're looking for a tool that's going to modify the geometry, that's going to let you change the geometry, the tab that you should be going to is usually going to be the Utilities tab. Now, there's some ones that get thrown out there, especially if you've been using the system for a long time, like Extract Edges. That used to be found inside of our Utilities button, and for me and a lot of people, it's still there. I all the time go to the Utilities tab looking for Extract Edges, forgetting that it's now on Create 2D, but it fits on Create 2D because that's what it's for. But for those of you that are used to having things in certain areas, which you may or may not, I just want to show you guys one little thing real quick, and it's the shortcuts. Right here. So we can go into the settings next to the undo button. And right over here on the left, you have customize ribbon and you have customize shortcuts. So if you want to make a shortcut, I shouldn't have said shortcut. Shortcuts are keyboard commands. You hit the keys on the keyboard and it creates or it pulls up that menu, whatever it might be. You could do that for just about everything. I think the only one I usually set up, which I haven't even set up here in version 34, the one I usually set up is select mode, because that button right there gets annoying to have to click every time I want to do something. There's a debate about it. I've talked to a bunch of people about it. It should always be on, but at this point, that's not the case. So for me, I like to usually set up a shortcut for the whole thing. But I don't use many shortcuts other than really views, just because I train people too much. And it's if I start using shortcuts, then everyone's like, what'd you just do? How'd you do that? So I'm not going to use shortcuts, but all you do to add a shortcut is you click on the shortcut you'd want, and then on your keyboard, hit the keys you'd want to use. So I could do like a Control-Alt-S. You want to be very careful doing like a Control-S, because that already has a Windows command that we can't override. All we can really do is double it up. So you'd be able to go into select mode by hitting Control-S, but you'd also save your part every time. Sounds like a great idea until you get a part that's way too big to save quickly, and it becomes a big hassle. You could also go with something like Control-Shift-S. Basically, what you're looking for is that it's currently unassigned. It doesn't matter which one you decide to use. That's always going to be, always just make sure that it says unassigned. There's some F commands, like F1 is the help topics, which you'll see I just tried to load that. F2 is unassigned. There's one of them on here that used to not say unassigned. It said unavailable, but it doesn't look like that anymore. So that's good news. I don't use F commands for that. So I'd do like a Control-Shift-S for select mode. And then I can hit OK or apply, and that will now be a key that I can use. Or got to hit assign first, and then I can say apply. So now I'd be able to use that keyboard shortcut. That's not what we came in here for. What I want to show you guys is the customized ribbon. A lot of people don't understand this. They miss this. So I just want to point this out. So we have the utilities tab up in the background. So that's the one I'm going to add to. And I'm going to put the extract edges button on here because I like it on there sometimes. So when we have the advanced or the utilities tab expanded here, the first thing we'll see is move, which is this whole tab here. Then there's trim extend, then there's break, adjust, and it's just down the list. And if you expand that, like move, you'll then get a button group. So this is a group of buttons. And if you expand that, you then get to see all of their features. Now, rotate has an arrow on the bottom, which means it has a drop down to it. So you're not just rotating with that command. You could be doing a rotate or a rotate 3D, depending on where you click on that button. So you can see that if you expand rotate, it's already there. Now, you don't get a choice of grouping buttons together like rotate is. Those ones will have this little arrow on them, and those signify that there's more options and that it's kind of a drop-down menu. 1 second, let me take a drink. All right. So now I want to go down until we find the extract edges button. And there is two of them because there's an extract edges and an extract edges from solids. So I would grab this button here that has the little arrow on it. Over here under utilities now, I'll shrink up move and I'll go down to properties. So I'll put the extract edges right there so I can turn it on and off as I don't need it. And so the first thing I'm going to do is I'm not going to make a new tab. I'm going to make a new group. So I'm just going to say I need a new group. And then I believe you could double click. How do I rename? Oh, rename. So there's the rename button there. And this is just going to be extract. Caps lock's on. Hold on. Extract ED edges. Perfect. All right. And then I can hit tab to finish doing that. So that's now going to have a new tab there. After I'm done with that, I just need to take the extract edges and say add. Now you can have a command doubled up. There's no issue there. So now I can go ahead and hit apply or click on this. And so right here down at the bottom, I didn't point this out. This is the button size. So if there's any features you use in here often and they're not, you want them to be bigger, you can actually come in here and make the buttons larger. You can make it a split button, a drop down button, or just a button. This one is a split button because when I click on this one, it's going to drop down and show me both extract edges and extract edges from solids. All right. So there we go. Let's go ahead and hit apply. There's our extract edges, hit OK, and there it is. So now it's a split button. So if I click on the bottom of it, I have the extract edges. So like I said, if there's any features that you would rather have in a certain place, or realistically, if you wanted to, you could go into the customize ribbon, and like right here, you'll see the home, create 2D. These are all the tabs that we have. Those are all those tabs along the top. You could come in and make a new tab. So I can make a mic tab. And this is all the features I use the most often, which really depends on what kind of work you're doing. A lot of you guys, the Create 2D tab is already there. It's got all the features you use the most often. But if you switch a lot between, Create 2D, Create 3D, and you want to be able to add them all onto a single tab, you could definitely do that as well. All right, we'll hit OK. All right, so now we're on the Utilities tab. I have Extract Edges. I don't need it. But right here we have Quick Trim. All right, Quick Trim allows me to click on an entity, and it'll trim that entity, in this case, from the beginning of that entity to its first intersection. All right, so we're going to go then past that and just trim off that full line. So then we'll do the same thing to the other side. And then this middle line here, you have a choice. You could trim this, but it's going to be a click here, and a click here. Another quicker way to potentially do that is to just use select mode. Click it. That picks the whole line, and then just hit delete on your keyboard, and you can just trash the whole thing. All right, now we're going to go ahead and quick trim out the arc right here. So I'll go here and here. And an important thing to note about this, how we drew this right now. Whenever you draw an arc, and it is at the, by its natural drawing state, the 0 degree position for your arc is going to align with your x-axis. So what that means is when I just trimmed that arc, I trimmed it from 22.5 all the way around to, I don't know what the number is, but it's minus 22.5. So these two, or this entity, what looks to be a single entity, is actually the minus 340 or something up to 360, and then from 0 to 22.5. So you have broken entities, which it's not the end of the world, and I'm going to show you guys how to fix it in a few minutes, but you do want, the best entities you can. If we were to go create surfaces out of that, there's potential that instead of making one nice clean surface, it has a line down the middle of it, like it's split down the middle. That probably wouldn't happen. Bobcat's pretty good about putting the surfaces together when they should be, but it is a possibility. All right. So I'll fix that in a we can fix it now. So to fix that, anytime you deal with a piece of geometry that should be one piece but isn't, it's because it got broken in some way, and I could simulate that right here. Now this line right here is right now it's one piece, but if I said break it into 50 pieces, I could pick it and hit OK and cancel out. We could now see a whole bunch of tiny line segments, but that still should be one single entity. So when we use this feature, it's up here, it's called Cleanup Optimize. Even if you know for sure, which with 2-axis, you can never be perfectly sure, I'll say. Sometimes you end up doubling geometry. It could be sometimes as simple as making arcs and hitting OK a couple extra times. I've done it many times. I'm sure we've all done it. When you have double geometry, now by definition, double geometry is two of the exact same pieces of geometry sitting in the exact same place. If you import a DXF, if you've ever imported it and you got two lines that don't exactly line up because they're not exactly the same, it's almost like they're overlaid on top of each other, but they are separate lines. The Cleanup Optimize will not fix that. But if they are two of the exact same lines, it will fix it. So you just go to Cleanup Optimize here, and then drag a box over your entire piece of geometry. It doesn't matter what you pick. This thing's either going to get rid of any duplicates or rejoin any geometry that should be rejoined. The only time you wouldn't want to use this feature is if you've intentionally gone in and done like a break many and broke apart into a bunch of intersections. If you did that, then yeah, you broke them for a reason. So you wouldn't want to rejoin them back together. And I've done that before just when I wasn't paying attention. but it's simply you just re-break it or you undo what you did. So cleanup optimize, just drag a box over the entire feature and then hit OK. If there's a problem, it'll fix it. If there's not a problem and there's nothing to fix, like if I was to go do this again, nothing happens. There was no corrections made. This feature by itself has saved me more time than any other feature in the system because I don't always find bad geometry. And I don't always look for bad geometry. I'm never, searching for bad geometry. It's a lot of times you go into it assuming you did everything right until proven wrong. So, it's a good feature. Make sure you use it whenever you're working with your wireframe, especially if you're going to turn your features into solids. If you're going to go start doing extrusions and stuff, you're going to want to make sure to do it beforehand, because if there's bad geometry on an extrusion, you'll get walls, but you won't ever cap the part off. And if you don't catch it, then you'll stitch things together, and it's a big mess that you do not want to have to deal with. So there we go. All right, so the next thing I want to do, just throw some 1/4 inch fillets on here. I'm sticking pretty much everything to about 1/4 inch just because that way I don't have to go real small with the tools. We could go with 1/8 inch. We could go down to 1/4 inch end mill. All right, we'll go 1/8 inch. So we'll go create 2D, and then right here, fillet. Now, because this is a chain and I want to do all 4 corners, chains is the best option. So go chains, and then I'm going to set my radius to 0.125. And then the way we pick the geometry is to hold shift and then click. And I'm going to show you an example of why you sometimes have to use the between two entities feature. On this part, we'll look at it. So we're just going to hold shift and click on just any line that makes up this pocket here. And there it is. We'll hit OK. And now we have a radius on there. So now I'm just going to cancel out. And I'm just going to go up to utilities and rotate. We need 6 copies total. All right, so we have 1. So we're going to go to rotate. I know that I need 6 copies, but sometimes for me, it's just trying to think of 360 divided by 6. The math doesn't just make its way to me. So you could type it in. 360 divided by 6 is going to give us 60-degree rotations. So we're just going to hold shift and pick our geometry. We're going right around XYZ 0. And I just realized this not long ago. Some of you guys don't know about the rotation center. I had a customer. He's been a customer for years. I've been working with him in tech support before I even joined training. And he called in, and I was chit-chatting with him because I saw his ticket in there, and it'd been a while. And he was asking about Rotate. This guy's been using the software for at least 8 years. I mean, or probably that's about when I got into tech support. So he didn't know that the rotation center was what you're rotating about. It's that whole thing that could change where your rotation happens from. Just so happened for all his years of working, he worked right around XYZ 0. And this was one of the first parts he ever imported and worked on. It was shocking. So the rotation center is the point in which you're rotating about the geometry. All right. And those arrows that are on there, let me set this guy back to 0. Those arrows that are there to kind of help you define exactly where you're trying to go. Because sometimes you just get confused. So right here you have like an x-axis rotation, which doesn't align all of my arcs around there. It just kind of flips the part around itself and doesn't really do anything for us. So now I know an x-axis rotation is not the right rotation. So how about a y-axis rotation? Well, a y-axis rotation gets us the first part, and it gets us, we'll call it the fourth part, fourth one, but no other ones. So you then figure out, okay, I got to use z. Z is definitely the one that can get into all the positions. And then you have to look at your angle. So again, we'll go 360 divided by 6. Now, the center point should always be in the absolute center of the geometry, but that's not where it automatically goes. If you have a piece of work, a part that you're working on, and you're working in this upper right-hand quadrant because you like all your dimensions to be in the positive quadrant, which is totally awesome. Brain doesn't work that way. Great, do it up there, but you'll have to move your rotation center point to the center of your geometry every time. which can get a little tedious. It depends on what kind of shapes you're working with. If you're working with arcs, you always have, if I go down here, or if I pick this thing, you always have all your snap points. So you can always find the center. But if you're working on like a rectangular part or just an odd shape, you'll have to locate the center. You might have to draw, a line from corner to corner on a rectangle and go from the center of that line. And you're just using that line for construction or something. So just, play around with it. If you don't know what it is, you gotta pull some measurements, find yourself center. But in our case, this is one of the biggest reasons why I don't draw in the upper right-hand quadrant. I like having the center of my part be XYZ0, because more often than not, I can rotate around that. And I can always move this part later on into the upper right-hand quadrant. So if I'm going to machine it because of, I want to move it over there to machine it, I'll just translate it later on. All right, so copies, we got our first, and then we need 6. So whenever you're doing copies in Bobcat, you take the total you need, you subtract how many you have, and whatever the remaining number is the number you need. So for us, it's going to be 6 minus 1 is 5. And so we make 5 copies, and that keeps the original where it's sitting. Hit OK, cancel out, and then I'm just going to go back up to a top view. All right, drink break, 1 sec. All right, and just a reminder, if you have any questions, just put them in the comments. Oh, I'm zoomed in. Hold on. There we go. Top view. All right. So we have our slots done, and now we can actually turn those on and off as needed. Don't need them anymore for now. Yeah. All right. So the next thing we're going to do is a hole pattern. And the hole pattern is found, again, we're doing Create 2D, so it makes the most sense. We could actually, we'll keep it just so we can visualize it. But I've had a bunch of confusion from a few guys recently about hole pattern, how you get holes to start at certain positions and act certain ways. So hole pattern, you click on it. And when it loads up, you're going to have your circular pattern or a grid pattern. All right, so you pick what you want first. We're going to end up doing a circular pattern. So let's look at the grid pattern first. The grid's pretty straightforward. The way it works is you define the width and the height. The thing to note about that is it's from the points in the center of the arcs, not the edges of the arcs. So if you were trying to go to the edge of an arc, the edge of your arcs, you'd want to subtract a few things. You'd have to do some math. I can't move my cursor. Actually, I could just hit OK. Or just put it down. I'll put it down on XYZ0. So the distance is from here to here is 2 inches for the width, and from here to here for the height. So just so you know that. Now the X is how many holes along that X axis are we going to put. So I could say let's do 6. And that'll give us a little bit more space because it's 2 inches with 6 holes on it. And then we have our y-axis, and it's how many holes are on the y. So you can see we have our top holes and our bottom holes. And so that could be a y of, we want 4. And then you just have a grid pattern of holes. I've worked with some guys that just literally make parts that have just thousands of holes on them, just a bunch of holes. So they just go in and make a grid pattern. And if they need them in some sort of custom shape, they draw that shape and then get rid of any holes that fall outside that shape. It's pretty cool. And then you just define the hole diameter. So you could say 0.375, whatever you want to add in. That's a little too big. I'd keep it at 1/4. Or let's say you're going to tap these holes. I would go with a hole diameter of 1/4 we'll say 201. And then 1, if you were to add those to a solid model. So if you were to actually extrude these through under the Create 3D feature, and I know it's not that day, but I'll bring it up. There's the Advanced Holes tab. And actually, you wouldn't need any of the arcs that are on there. What you'd actually want to do is just create points out of the centers of all those arcs, because you can't do a grid of points. So I'll show you real quick. You break the arcs like so. Let me do this first. Add a new layer. Let's put this on the hole pattern layer. And so, yeah, that's all fine. So you put your hole diameter in, and then you'd say break arc. What that does is it ungroups all of these holes from each other. Otherwise, they stay grouped, and I'll show you that here in a minute. But I'll turn off this other geometry, and then what I do is just go to Create 2D, Point, and then right here, there is a Point from Entities. And you just make sure that arc center is checked and uncheck anything else to check. We just want the center. Drag a box, hit OK. And then in your, if you were to do this, again, this is more something we'll do. I think it's supposed to be next week is 3D day. But if you were to do the holes, you would do advanced holes. And that allows you to come in and say, I just want to create a hole. If you want to counterbore on it, you could do that as well. And you'd have to define all that. But I could come in and say that these are, again, this is all just strictly if you're adding these to a solid model, just to beware. There's no properties. There might be properties. Well, look, it's under the utilities tab. We might be able to add properties. But we could go in here and say UNC, let's go quarter 20. And then I could notice I can only pick points right now. It's only allowing me to pick points. So I could drag a box is what I'm saying. We could drag our box, and that's actually going to construct these holes. And again, you could do counterbores on top of them and stuff like that. So not important, kind of a side note, but when you're doing your hole pattern, or if you ever need a group of points for whatever reason, if you could make it out of a circular pattern, you can then go in and add those points to it very easily. You could then get rid of all those arcs. Right here, you grab your select tool, go up to the pick match option and say pick match radius. You pick that, you pick any one of those radiuses, and any radius that matches will be selected. Now, you do have to be careful with that, because if you have like a 1/4 inch hole and you have some 1/4 inch fillets on your part, it will grab those fillets as well. So sometimes it's not the best way to do it, but we'll go ahead and delete that, and I'm going to delete all those points as well. All right, so we'll go back to our hole pattern. And let me just turn on just the visual on this. There we go. All right, so then we also have a circular pattern. Now, the circular pattern is a little bit more confusing, but it's really because of the angles you have to worry about, or you have to think about. So the first hole that you create, you need that in the right position for the rest of the holes to follow properly. So if, say, our first hole needed to start at 45 degrees, we would need to come in and set our start angle to 45. But notice that's not an even hole pattern anymore. And the reason it's not even is because we're only giving it 315 total degrees to put that rotation around. So it's going from 45 to 360. So basically, the thing you have to remember if you're doing this is you have to add your start angle into your end angle just by plus 45. And then that way you're giving it 360 degrees to work around still. And then you define the diameter, which I think 2 is fine. Let me turn on the counter bore. Yeah, that looks good. So 2 inch, I'm pretty sure that's what I did on the other one, because it's the default. So 2 inch, we'll go 6 holes, 201 diameter, because I'm going to tap them just for fun. And then right here we can, really at this point it doesn't matter. I'll leave them on, because if we do need them, I'll change it. But we'll go ahead and break arc. And then right down here, I didn't point this out on the last one, but you can control either the center of the grid, the exact center, or the bottom left-hand corner, which would be, if you were to draw a straight line up from my curve. Let me just put these down here. And I'll hit OK, or I'll click on the Z right there. All right, so that's where I want them. All right, just so we could, so that's how we can visualize that. So this is going to center it on the point, or it's going to use the bottom left-hand corner. So it's going to draw a line from, well, this one's been rotated, so it's actually a different line. That's why it's off a little bit, but it's going to center it from the either center or bottom left. Center is usually easier. So there we go. All right, so we now have our hole pattern in there. I did get it on the correct layer. So there it is. Now let's compare to the drawing over here. We have just the cutouts to do. All right. So the cutouts are pretty simple. They're very similar to a part I've done many a times for these things, and I didn't want to do it again, but it works because I want to show you guys the 2D Boolean feature. So what we're going to do is just use a pretty much a rectangle to cut out that section, but we have to define it properly so we can center it up on there. So it's going to be a 2-inch wide slot or groove, whatever you want to call it. And then we're going to do let's go with a width of 1. There we go, 1/2 inch deep. So there we have it. Now what I want to do is make sure we have our radiuses added onto this right at the start. So I'm just going to turn on these 1/4 inch fillets. All right. And that's the default. And then right now it's asking where the base point is. I'm in control of the center of it. You could use any point, but I want to center it right here on this top snap point, just like that. So then I'll go ahead and cancel out. And there we have it. So now we're going to do 6 of those all the way around. So we'll just go up to Utilities and Rotate. And again, the angle is going to be 60 degrees. And we're going to need 5 copies. And we're just going to hold Shift and pick that whole shape. And it's going to copy them all the way around where we can then hit OK and cancel out. Now you could go in and quick trim this. And that'll absolutely work. It's just a time consuming one because you got to think it's 1, 2, 3, 4, 5, 6. 6 times 6, that's 36 clicks to do that one. It's you could definitely do it, no big deal. So the feature I'm going to show you, I call them luxury features. They're features you don't need, but after you get used to them, you like them. And after you know how to use them, they can come in handy. Now, there's definitely a time and a place. Quick trim should always be your go-to option. That should be the first thing that pops into your mind. And then if you remember that this 2D Boolean exists right here, then you'll use that. But a lot of times there's some things that the 2D Boolean cannot do that the quick trim does very easily. So we go into 2D Boolean, and you have 3 options. If you've ever done any solid Booleans, which is subtracting or adding solids together, that's essentially the same thing, but with wireframe geometry. So you have a first group and a second group. And when you're doing add or intersect, you just need to follow the preview. They all kind of, if you pick them in the wrong order, they can definitely get weird on you. But basically think of it as add is going to incorporate all the geometry and make it one piece. So for this part, it would delete this section of geometry on all the pockets, and it would go around, and we would have these weird, bosses on the outside of the part. Intersect keeps just the area that intersects, so it would just keep this area. And both of those features, there really is no right or wrong. But subtract, there is. So with subtract, and it's the same rule when you get into 3D, is you pick what you want to keep, and then you pick what you want to remove from it. All right, so the first group for us is going to be this arc, but I'm going to do it backwards, and I'm going to pick all of these pieces of geometry around here. So that takes us to 6 shift clicks. So we had to hold down shift and click on those 6 times, so that's a lot better than 36. And then I can go ahead and pick the arc. Now, as you can see, the top, sorry guys, I smacked the microphone. The top of this arc, or the top of this box, this orange, it might be, hopefully you guys can see it. It's pretty faint even on my system, but it's a darker, it's a brighter orange. That's my preview color, and I really should change that back to green. That's my preview color. And so it's showing me that that is what will stay if I hit OK right now, which I don't want that to stay. I want to do the opposite of that. So if you think about it in the way I said it a second ago or a minute ago, you pick what you want to keep, and then you pick what you want to remove from it. And again, the preview will show you exactly what's going to happen. So you can see we're going to keep this section here. So I'll hit OK, cancel out, and that's where we then get all those cutouts around the part. All right, and the last bit is getting these fillets on here. Now, I don't know if you guys have ever had to, but there's sometimes a fight you can have with fillets. I'm sure we've all dealt with it. In Bobcat, it's because of the length of the chain that's connecting to the fillet. Yeah, that's perfect. That's exactly what I meant to say. So like right here, I have a pretty long chain and a decently long chain. So if I go with a radius of say, 3/8, I have, well, technically, let me just do a measurement real quick. I'll go evaluate, measure 1. The length of that chain is 0.5011. Again, to take a quick measurement like that, you go to the evaluate tab, measure 1, and just click on, make sure you click on the line, not the points that pop up. Otherwise, you'll just get a point measurement. It doesn't help me do nothing. And yeah, through there, you can see all that information. If you want to measure between 2 points, you go measure, and then I could go and say, I want to go from that point there to that point there, and you'll get a distance in X, Y, and Z. So just so you guys know, helpful little tool. So let me remeasure this line, 5011. So the largest size fillet that I could put on here that ends right at that value would be 5011. So if I go create 2D, we'll go fillet, and we'll go just we'll do a single corner, or actually I'll do between 2 chains. There we go, that'll work. And we go 0.5011. This is either going to be too large because it's the exact size. There we go. But if I was to come in here and just do like a, let's see if let's go a little bigger. But let's say we go 502. Let's deselect that and try it again. It did still work. It's got enough space. So that's really the segment, I guess, because we're on an angle, that might be a difference. So we'd have to find out the maximum, but it's the maximum you could fit in there. And the problem you run into when you're doing sharp ones like this with a big fillet here is that tiny, that tiny line segment that's there. I can only go and fillet this if I go to my fillet command. There we go. If I was to try and do, 502 is going to be way too large, but if I said, let's fill it between this and this, it'll do that weird, goofy fillet like that. And it's just not right. So the way that you have to do these ones is you have to set up your fillet size. So we'll go 0.25. Actually, I think let's go 0.125 on these. And so we could try and put our 1/8 inch fillet on there, and you'll see it really has to go pretty much down that far for it to work. Like that's kind of how it shows it. Not going to work. But if I go from this arc to this line, I can fillet it. And it leaves that little section there. It doesn't trim that because it wasn't part of the process. But I'll show you guys a real quick way on how to do that. So you have to just kind of skip an entity. You could just delete that line before you did all this. Single corner click or chains wouldn't work. So you have to do all these ones with the between 2 entities. And yeah, it's just one of those tricks that when you know it for fillets, it makes them a whole lot easier when you're struggling to get a fillet to fit onto a corner. Sometimes you have to go to that next entity or even further. And other times with arcs and stuff, especially if you're trying to do a fillet between 2 kind of arcs that are sitting next to each other, sometimes knowing that you have to break the arc and get those smaller segments or go to those next segments works. So there we go. We got them all taken care of. And now we have all these extra pieces. So there's a bunch of ways you could go about this. Picking small lines, it's not super difficult, but it is more difficult than picking big geometry. So what I could do is, because we drew this stuff correctly, we could turn off things we don't need until we're left with just the why is that disappearing? I switched layers at some point here. The base. Oh, the base got moved. Okay. No big deal. So a really quick way of grabbing that geometry, what I do is grab the geometry you don't want first. So I'm just holding shift and clicking those. With arcs, you don't really have to hold shift, but shift click, grab the geometry you want, then drag a box over all the rest of the geometry. And it'll deselect your stuff from before. Select all those mini lines, and then we just hit delete, and they disappear, and I now got clean geometry. So let's fix these layers real quick. So on the base, I want that, and I want this right here. So I'm just going to hold shift and pick that. To change the layer, there's a couple ways. Right over here is a button that you guys can use if the check mark is on the correct layer. So what this does is it takes any geometry you have selected and it moves it to your active drawing layer. Your active drawing layer is the layer with the green check mark on it. That tells Bobcat at any point, whenever you're working on, whenever you're drawing something, that tells it which layer to go to. So I'm just going to say, yeah, let's move that to the current layer. Cancel out. I always cancel out. And then if we turn off the C-bore layer, it gets rid of the counter bore only, which is perfect. That's what we want. All right. Any questions so far? That should be it. We're going to start looking at the cam. And yeah, there we go. All right. Onto the cam then. So we got to think of some things here. And let's do this. Let's go to evaluate. And I want to just add notes because this will just let me pick a spot, right? So I got to pick an entity. Oh, maybe let me see. All right, so let's do this. I want to make this easier for us when we go to machine this. So I'm just going to go to the text real quick. And we'll make it a 1/4 inch tall. And I just want to define kind of the depths of everything real quick and easy. So we'll say it's 1 inch thick. 1 inch thick. All right. Ooh. So, yeah, that'll work. All right, we'll grab the center of the text. And I am just going to move this up to here. So we know that that is 1 inch thick. All right. This is where having a solid model, and if I do the 3D one, oh no, I'm not here next week. The next time I do the 3D class, I'm going to use this part just as a quick tutorial on how to go through. Unless you guys want to see it later on, I could definitely do that. But I'll go 1 inch thick is the thickness of the part. Those holes are going to go through. I don't need to note that for myself. That hole is going to go through. We're going to send the counter bore an 1/8 inch deep. We'll say 0.125 deep. Oh, dang it. Hold on. Can I get it? All right. So 1 inch thick. All right. We'll hit OK. Put that down first. There we go. And then we'll go 0.125 deep. And I'll just, we'll resize that. Let's go down to 0.1 because I can read that later on. Hey-oo. All right, so we'll put that there. That's fine. Oh, I should be putting this on a text layer. Hold on. Text. All right, the pockets will go, let's do height. Let's go, the height's fine. Let's go 1/2 inch deep. 1/2 inch deep would take us through. Let's go 3/8 deep. And then we'll put that right there. Okay, that's enough definition, just so I got it. The stock will get created. All right, that'll be perfect. And then what we'll do is we'll do this on both sides. So when we do our stock, we'll have to we'll do it this way. All right, so new job. Gonna do my stock wizard right here. And I don't have a solid. The workpiece is only going to ever be a solid, so you got to make sure you have that. And then I need to just hit OK here real fast. I need to get this, and this onto my active layer so I can hide it for now. I know the thickness of the stock. All right, so we're going to do our stock wizard now. And with something like this, I'd probably go for a round piece of stock. And the way you use this is always turn on bounding cylinder. Otherwise, if you're doing circular parts, like right now a square, well, let's just see if we do a bounding box, we can calculate. It's good because I have rounded outer part here, and it is 6 inch diameter. But if this was made out of, it happens on the one other circular part, it ends up with a weird odd number of like 5.891 because you end up cutting off corners on it. So all you got to do is either bounding box. Usually, though, bounding cylinder is going to be the better option. It gives us the same result here, but it's a better option because it fits to the full shape, not the center of a square. So just so you know. Or if you ever have odd shaped stock, like you just had one of these instead of a whole thing, so the rest of it would be this diameter here and one little bump out, you'd still want to use a round piece of stock, centered fully. So there we go. So it finds the full stock for you. That's all I'm trying to say. Next, we get to our machine setup. With a round part, I'd like to start, right in the middle if I can. I feel, that's the easiest thing to locate. Down here, we'll do our work offset 1. And the only thing I'm going to do different than a normal, than a lot of you guys might have to, is I have to add a work offset for Z whenever I pick the origin of my part on the top or the middle, because that's the point that Bobcat puts in the center of the virtual machine, which the center of the virtual machine, the virtual machine home, is not the same as your machine. Your machine's going, might be up in a corner somewhere. This goes to the center of the table, no tool in the spindle, with the face of the spindle touching the table. That's the home position, unless your spindle can't touch the table, in which case we define it properly. So by me not adding in a shift here, and I'll just say 1.5, my part ends up in the table. If any of you guys have the Machine Simulation Pro, which I really only recommend if you're getting into 4 and 5 axis, for you, 3 axis guys, it's not going to be a super needed thing. But if you are getting into 4 and 5, I suggest it. You will experience the parts being inside the table because you'll be able to actually see the physical table, and you'll get a bunch of errors telling you that you're machining through the table, which is good to know because you messed something up. But it lets you watch the simulation. You just don't see any other potential collisions because you run through the table so often. So just a heads up for anyone. And then the clearance plane. So this is the safe area above the part that the tool is going to move around safely in. So you want to make sure it's tall enough for any clamps, anything. You want to make sure you can clear everything on that part. If you got bolt heads sticking out, 1 inch is the default. There is no way to change the default yet. I'm hoping in the future all these things will eventually be a little save button next to them would be nice. But that's not happened yet. I don't know if that's ever going to happen. Don't hold me to that one. So the clearance plate just defaults to 1 inch. Then you can go ahead and hit OK. Or change the clearance plane, your choice. So there we have it. We now have our stock, and it's a round piece of stock. I'm going to say that it's turned to size. We're good here. So we're not going to we don't really have to machine all of it. Now we could do that. I'll show you guys how to do it. So we then would go in and make sure we have the correct material for that part. And right now it's set to aluminum. This is just for feeds and speeds calculations. And there's a lot that factors into that. The entire tool library, which we're going to look at here in a minute, is set up as high-speed steel. I might as well just go into it. So what we're going to do next is we're going to build our tool crib. We're going to pick out the tools we're going to need. And yeah, that'll be fine. What did I make those? Those are 1/8 inch. Or are they? Those are 1/8 inch. Those are 1/8 inch. What are they? So we got to use a 1/4 inch tool for that. All right, good. Couldn't remember. All right, so we're going to go into our tools, go down to our tool crib, and this is where we store the tools specifically for this job. All right, so we're going to say, well, let's start by the easiest way. The easiest way to get to the correct tool is to first click on it on the left. So the first tool I want to bring in is going to be I'll use my 1/2 inch 90-degree spot drill. So I'm going to go to my center drill category. Now, the reason this is faster is because it brings us directly to the center drill category. If you're on all tools and you load into that, you then have to sometimes open up submenus to go from drill to mill. It just saves you a second. So click on it here on the left and then add from the tool library. And that way it specifically brings up the center drill category. Just a little speed saver for you. So whenever you're picking your tools, especially if it's the first time you're doing it, double click on it and look through the tool. A lot of people just grab them. I'm guilty of it too, without looking at it. And so you end up missing a lot of times the tool material. You'll be running a carbide tool and it'll be set to high speed steel, or vice versa. Or maybe you're running an insert cutter. You need to make sure that that's set up correctly. If you're not doing that part, your feeds and speeds are going to be wrong anyway. This is to help get you closer, as close as it can, because it has it knows the feed per tooth and it knows all that stuff. It calculates it correctly, but it might not be the exact stuff for your tool. So that's going to be a big part of it. I use a program called GWizard. I love it. It gives me all the values I need to know. The learning curve was easy. It's one that can definitely help out. It's a big help if you struggle getting feeds and speeds. It's got all different materials, all different tool materials. Check it out. He's got a really good demo. So I'm going to go with carbide. And then I'm not going to, if you put a holder on it, you can. It's just, you have to assign the tool holder to, whatever you want. But if you do it here and now inside the tool library, it will be locked in with that holder. So anytime you pick that tool, it'll grab that holder, which isn't a bad thing. You'd have a holder on all your tools. But for 2-axis, as long as you got the tool sticking out far enough and you can meet all your, total depths, not a big deal. All right, so we'll go ahead and I'll say okay, and that's going to get added to my library. Now, we're going to tap those center holes, but Bobcat always picks the drill for us. So I don't have to add the drill. It also always adds the tap for us. Excuse me. And so I only need to really define the center drill I plan on using. So that's all I'm going to define for that. I'm not going to grab the drill unless you have a special drill. So now we'll go down to end mill rough and add from the tool library. So the first tool we're going to use I didn't add any face material. I'll do a face. I don't want to do it my way because it's confusing. I'll grab a tool. Let's see. We'll grab a 1.5 inch insert face mill. So if it has the name insert, you can assume it's an insert mill. So that should work. We'll hit OK. We'll go back and add a little face material to run a face pass on it. So we got our 1.5 inch insert face mill. We'll add from the library. Next tool, if you want to go with something to kind of hog material, we could do a rest pocket with this. Realistically, I'm just going to go with something like a half inch flat, and then always look at the flute length that's defined in our tool, and then double click on it, make sure it's the right tool material, whatever you got. I need to go at least 1 inch deep, so the standard should work. All right, we'll go there and hit OK. And then we need a 1/4 inch, so we'll add from the library. I don't usually, just so everyone knows, I don't usually jump back and forth between the end mill rough and end mill finish. Most of the tools are the same. If you do have a different set of feeds and speeds and you customize your feeds and speeds that way, then it could matter more. The end mill finish category does have more ball mills, so I do use it a bit more when I'm doing 3-axis. But most of the tools I pick up, most of the time I'm defining my own feeds and speeds. And so I just, pick the tool that I just pick it from the end mill rough category. So just so you guys know. So this one's a 1/4 inch flat end mill standard. Let's sort our diameter here. And we need the 1/4 inch flat end mill long, because that's the one that's going to be long enough. Because we're going to finish the outside from this side, and then we'd flip it over, do the pockets and the counter bore. Really, that's all we need. So we'll go ahead and hit OK. And adds the 1/4 inch flat end mill. And that should be it. We'll be able to use the 1/2 inch right there. All right. Yeah, that should be good. And then also out here. All right, good. So if we need more, we'll add more. All right, so I'm going to go just make a quick change to the stock real fast. I'm going to edit this through the stock wizard. I just want to add some on the start face. We'll add, 100 thousandths. And on the end face, I'll also add 100 thousandths. So we'll face the other side as well. And so we'll just go next. And now we have to change our point. We actually have to make sure to pick the new top point, which is going to be 100 thousandths higher. So let me go and say origin, pick that top, and then 1.5 is still fine. So we'll hit OK. So stock's now good. That kind of thing happens. Try and catch it, I guess, is before you start making toolpath is really when I double check that. Make sure you get some, if you're going to face it off. There's also the option of setting your stock up to the exact thickness that you want. And then I have one customer that when he faces off his part in BobCAD, his extra stock is 0. And the amount that he cuts on his face pass is 0. So what he ends up doing is, because he's technically cutting a 0 pass, it's wherever he sets his Z. So he touches off his rough stock and then drops Z down on the machine, and then he zeroes it out again. And then when he runs his face pass, wherever that tool's at is where it runs and makes the top. And then when he flips the part over and gets it all measured, he then knows how much he's got left. So with that same face pass, he'll just drop Z, set 0, run the pass, and then adjust from there to get the perfect thickness. So he doesn't even add extra material in his stock wizard because he's going off the rough stock, and then with his face pass, he's creating 0. So he never has to deal with tool paths with negative. I mean, you still do if you're doing pockets inside of pockets and stuff, but he never really has to deal with that negative 100 thousandths automatically being on his features. It's a cool idea, confusing to some, but it's actually become one of my preferred methods. But it's got its limitations because, I mean, they all have their limitations. Who knows if it's actually going to be 100 thousandths on top? So, yeah, that's another way to do it. And I believe in version 33, I think it was 30. It's 32 or 33. There's the adaptive facing pass. You couldn't do it that way. You could do just a standard, zigzag or zig face. But I think they fixed that in 34. So if you want to try it with that method, if I explained that good enough, I think I did, let me know how it goes. All right, so I'm going to, just face this thing off first. So we'll right-click on Machine Setup 1. This is the easiest, tool path of them all, really. We're going to go mill facing. You don't pick the geometry. It reads the geometry. So we go next. Right here, it knows the top of features at 0. It knows the total depth is 100 thousandths. And I don't have any bosses or anything that are standing up that I don't want to machine, so I don't need to worry about internal loops or a bounding box. Bounding box just turns any shape into a square, essentially. Next, we have our strategy. So we're just going to choose facing. It's already there. Posting, no real change to anything here. You just got your work offset 1. Next again. The roughing tool, it's got the 1/4 inch flat end mill. It does that. I don't know why. I'm going to go to the tool crib, pick my 1.5 inch face mill. And there we go. It's got feeds and speeds. This is where I'd pull up GWizard and see. It's not bad, though. And then right here's our pattern. So you got a zigzag, your standard, back and forth face. And when you're defining either the zig or the zigzag, the zig just rapids back to the beginning and make sure you're cutting in the same direction. With those two, you can go on or off the workpiece. On the workpiece is going to just end it at the edge of the part, feed over, and then cut back. So you're not getting that release off and then back in. But you can define a distance that you want to go past. So if you were to say 100% of the tool diameter, you're basically going off the workpiece that far. So off workpiece, you could just tell it how far off the workpiece you want the tool to come off, then feed over, then go. If you don't want it to, feed and cut while it feeds, then make sure your distance is at least, but I'd say usually over half the tool diameter. So if you're using a 1.5, I'd go, 0.8, 0.9. That way it comes off, feeds over, and then cuts back. And again, if you want to make sure you're doing everything in the same direction, go with the zig. The final option is adaptive. And this one is going to keep a constant engagement on the material as it cuts around. It usually turns into a spiral pattern, but the pressure on the tool, it should stay pretty consistent throughout the cut. So up to you which one you want to use. I'm going to go with just a standard zigzag and go off the part by 800 thousandths. And I want to face it along my X direction, which is the red arrow there. And so we'll say X direction. What's that? You could go Y or you could go custom. So if we want to go something like 45 across it, we could do that as well. We'll just say X. And then you could just tell it which corner you want to start in. So, upper right, think of the circle right there. So it's going to start there and cut back and forth this way. Or we could have it start here, go back and forth, whatever. The step over, it's a percentage of your tool diameter. And from if you guys do look at that GWizard program, I would also just suggest sign up for his newsletter. He does it's weekly, but he's got a lot of good tips and tricks. One of them that I spotted, I think last year or so, talks specifically about 50% step overs and how your tool just hates having that leading edge of the cut right at the center of the cut. So I've started doing 60 when I'm facing. The first cut offset is essentially to give you a bigger bite on your first cut. So it's a distance from the edge of your part to your first cut. So normally you don't want to go I wouldn't go 0.75. I'd probably go 0.5, and that would give you closer to a 75% step over. But I'm going to leave it as 0. For the parameters, it's just our bottom allowance. That would only ever be used if we were doing another face pass, maybe a cleaner one, different feeds and speeds, something like that. Otherwise, I'm going to leave that at 0. Right there, we got our depth. We could either go with a single step and do it all in one shot, or we could do multiple steps and break it down into however many steps we want. I'm going to go ahead and single step it. For the leads, you can lead in vertically. It's going to plunge down. So really, this one's going to be more important if you were doing the off work piece and you didn't make it long enough. If you only went off the work piece by, say, 0.4, it might plunge down on the part, which would not be good with this kind of cutter. So we would go with a parallel, and then I usually just do at least half the tool. Once again, I'll go a little over and just go to 0.8. So it's going to lead in that far and lead out that far. Lead in, lead out's the same as lead in. So next, right here for the links, just how do we connect when we get to the end? Direct or with an arc? Your choice. And finally, the advanced feeds. Now, if you have a machine that has an issue called dogleg rapiding, the convert rapids to feeds is to help take care of that. And essentially, a dogleg rapid is a rapid move that instead of moving in a straight line, it moves at a 45-degree angle until one of the axes reaches its position, and then it feeds down the rest of it. A lot of machines do it. A lot of guys don't ever notice it. A lot of it comes down to your fixturing, how you hold your parts. If you don't have anything above your part that you could potentially run into, you don't really notice it. So a lot of the guys that do a lot of the 2-axis work, it's not something they run into super often. But if you ever do see it, it's happening because of the rapid move, because all your axes move at full speed. So essentially what this does is it converts your rapid to feed moves. So it takes the G00s out, adds G01s in, and allows you to define a feed rate that is essentially your rapid, but it ensures that it moves in a straight line and not that zigzag. There is a setting for it inside of the current settings for the machine for you to set up. So that's the convert rapids to feeds, and then the lead in and lead out feed rate percentage. It's a percentage of your cutting feed rate. It's what you'd want to use on your lead ins and lead outs. So if you want to lead in into the first cut of the geometry at 50%, you'd come in and say, let's start at 50%. And then as it gets into the cut, after it finishes the lead in, it would go back up to the full speed. All right, that's it for the facing. So we're going to hit compute. And the one thing I haven't done is save this thing. So let's give this a save as. Let me just go to desktop. I have the repeat training documents to access. I'm just going to call this, look at that, example 3. Oh man, I can't, this caps lock is getting me. All right, example 3. And I'm just going to slap today's date on it so I remember. 11/16/2021 live. 2D. I like this part. That's why I'm keeping it. 2D live event. Not a bad one for you guys to save if you're following along. If I've moved too fast on anything, let me know. I could go back and redefine it real quick. Let me save that. And that's it. Let's blank that out. So actually, let me do this real fast. If we want, I just saved this. Well, I'll finish the tool pathing on it. I was going to say, I can't get it to you. There's no way to transfer this to you guys. So if anyone wasn't keeping up, I'd be able to transfer it. I'd have to email it to you. I could do that. If you guys are interested, throw that one. Just give me a yes in the questions, and I think I could copy your email right from there and send it on my other screen. All right, let me know. All right, so we have our facing. That's all done. If you want to look at it, I did blank it out. For those of you using 33, if any of you guys are still on 33, all right, give me 1 second, John. Let me just pull up my email here. Yeah, I think I can. So give me 1 minute. Oh man, people are sending me messages. All right, so new email right over here. So let me save. We'll save that right there, and then let me attach it first because I always forget that part. There we go. 375 kilobytes. Let's do that. So let's go live. Let's go 2D live event. I'm going to start it with Bobcat. 2D live event. Part file. All right, cool. So if I send this all to you, all right, can I get your email? Copy email. All right, whatever email you guys use to log in today is the one that I'm going to send this to. You guys will, yeah, I'll send them now, and if anyone else needs it, copy email address to clipboard. Boom, boom. Dan, got you. Rick, working on this right here. Rick, right there, got it. And John, I didn't get you yet. Okay, good. Copy email address to clipboard. Right there. All right, if anyone else needs it, let's see. So Dan, all right, I got the 4 of you. Cool. All right, so I'm sending that off now. Might take a minute. It'll be there soon. And then if anyone else gets it, I think some other guys might not be. If you're not sitting at your computer right now, you missed all of this. So probably missed that too. All right. Let's keep going. So the feature mill facing right there, we got our face. That's all done. It will have that on the part file you guys just got. So you could ignore that one. You could remake it, do it however you want. All right, we'll give it a minute. Give that a minute to show up to you. Yeah, I'll get it to you, Brock. Wait till the end, I see. No, I'm just kidding. All right, so inbox. Nope, sent items. Right there. Let me forward that. And wait, Brock, didn't I think I sent it to you already. Did you ask for it a minute ago? I'll send it again. Yeah, I already sent it to you. Okay. All right, so John just got it. So it should be showing up in your guys' email. Yeah, Brock, check your email. I think I sent it twice to you now. But there you go. All right. Let's do it to it. All right, we got to now do, let's think here. I didn't even plan on how we were holding this thing. Didn't plan it. We'll pretend we're holding it. I didn't think of it. Let's do it. We got one of them 5th axis vices. We're holding on to 100 thousandths at the bottom of this guy. 50 thousandths now. Yeah, we're holding on to something. I didn't plan that part of it on what we're holding on to. We might have to add more stock. I mean, we're not really doing it, but I'm just trying to think of when we go and do this outside cut, we need to be able to get around there. We'd either do half of it, flip it, do the other half, or try and go the full depth and not have all the marks in the walls. We'll figure it out. All right, so there we have it. And so I'm going to blank out the stock. I don't know why I've left it on this long. Get rid of that stock. Blank that thing out so you could see the part. And there we go. So let's start off with, we've just faced it. We'll drill the holes. And then we'll bolt the part down. That could work when we do the outside stuff. So, all right. So we're going to go ahead and right-click on the machine setup 1 here. And I'm just going to go down to hole recognition only works on there. So we're going to just go to mill tap hole. There's no quick way with this one. Yeah, we don't have a solid. So all we're going to do is say select geometry. And a quick way to pick the holes, I showed it earlier, but if we go up to home and then the pick match option, we can do a pick match radius. That way we could pick that and just get all those, just get all 6 of those holes in one shot. All right, 6, yeah. And then after you get that, go ahead and hit OK. So it's got the hole diameter, and 1/4-20 just is the automatic option every time. So that's what it grabs. And we just have to either punch in the depth now or hit next and punch in the depth on the next page. So we're going to tell it we're going to go, we'll go 1 inch. And then because it's a through hole, this is an important button here. Because it's a through hole, Bobcat on our drill is going to automatically add 50 thousandths. So we do want to make sure we have enough. All right, so we'll go next. All right, so right here we have our group retracts. This is basically your clearance plane. And so you can go to a plane. If you're doing 4-axis, you could go to a cylinder. If you get into 5-axis, you can use a sphere. You could use all that stuff in here now, but a plane's usually what you'll use for just normal drilling. And then you set up the height. It just uses the clearance plane by default. Hit OK. Now, if you ever have a negative top of feature on your hole and you set your depth, if that negative top of feature, say there's a wall in between some of your holes, something like that. I have some examples I could show you, but the rapid plane is what's used to connect from hole to hole. So if you have a negative top of feature at anything greater than your rapid plane, so anything for me would be over 200,000. So if it was, negative a ½ inch, that means you're only going to lift up 200 thousandths out of the hole and then feed. And if there's any geometry in between your drilled holes, it will rip right through it. Just so you guys know. So the adjustment would be either change your top of feature, which could mess with your drill times. But really, if you have a negative top of feature, add that to your rapid plane. So whatever, if it was minus a ½ inch, you'd come in and say plus 0.5, and that would account for that ½ inch plus the 200 thousandths that should be your safe area. Just so you know. All right, so again, diameter is 201. That was really just because I put those holes in. It's gonna, that's the tap size I want to use, or the drill size I want to use. The thread knows this, so I didn't even have to put it in. The thread type, through hole or blind hole. The difference is the blind hole doesn't get that added 50 thousandths on the depth, and whether it's a right or left-hand thread. Next, now, right here you do have a pick top, pick bottom. If you have a solid model, that's what you'll use it for. Or if we, for whatever reason, sunk our geometry to where it was supposed to be, that could do it as well. But I feel like that takes longer to do than our little notes that we put for our text. All right, so we have a tap or a rolling tap. And with either one of these, you're going to get a center drill, a chamfer drill, and then a tap. I'm going to go ahead and get rid of my chamfer drill, and I'm just going to close out of it. I'm just going to sink my center drill a little deeper and get it. So we'll go next right here. Right here, we have our machine sequencing. So you have closest, pick order, X direction, Y direction, custom direction, or optimized. Optimized is usually the one I'm going to use because it takes no thinking. It does the thinking for me. What optimized does is it picks the most efficient pattern out of closest, pick order, or the X or Y direction. So yeah, next. Well, start location, where are we starting? Bottom left, whatever. Right here we have our posting, work offset 1, next again. All right, for the center drill, we have our 1/2 inch 90-degree spot drill that we brought into there. Feeds and speeds, all that stuff. And then right here we have our depth. Now, I like 90-degree spots because it lets me think of a chamfer a little bit easier. If this thing's done and it makes a 1/4 inch hole, and I want a little chamfer on it, I could tell it to go to a center diameter of 0.26. So it knows to go to 0.13. There we go. So after that's done, we have our single depth, whether we want to peck it or whether we want to fast peck it. And really the big thing, if you want to use a fast peck, you just got to make sure your post processor has it. If you don't know, try it one time, read your code. If you do know that it doesn't have it, give a call into tech support or go on the new Bobcat support site and just tell them you want to add that to you want to get that added to your post. And as long as you can show an example of it, we'll be able to create it for you. So, or it depends on your machine. All right, so there's our drill. Again, Bobcat always picks the drill for you to match the exact diameter of your hole. Even if it's a really strange size, just a random number, it will make a drill that fits that. It's just a custom created drill. It doesn't get added to your library or anything. But just be aware that that does happen. So if you have a specific drill you want to use, just draw your holes to that size. Yeah, David, you're right. So David just said, even after the facing operation, isn't the stock still 1.1? Yeah, because I got the other side with the face. Yeah, we'd have to go back and fix that, which we'd catch that in the simulation. It's more of, I would just be sure that the tap doesn't, well, I mean, we need to tap it all the way through. Yeah, no, we definitely have to open it up. Yeah, we'll have to go at least 1.1, which we could change really on the next page or back. So kind of either way you want to go about it. So we'll go ahead and hit next right here. And this is the drill. So our effective depth is that 1 inch plus the 50 thou, which as David just pointed out, we need 1.1. So yes, we could go back to the beginning, and this is probably where I'd do it. This is where I'd recommend doing it because it's going to lock it in. We could do it on the other page as well, but let's say we just want to go 1.2. So this is actually going to add on the extra 50 thou still, which I'm fine. We'll go that extra 1/4 inch deep, but the center, the tip of the drill is actually going deeper. So the number we should output in the code is going to be this 1.3104. So we do want to make sure we take that into account and we do it that way. Make sure you have enough space under there. Yeah, thanks for pointing that out, David. Absolutely right. So now we're going deep enough. The tap can clear through. Again, you can choose whether it's a single step, a peck, or a fast peck right there. Next, we have our tap, which it grabs a 1/4-20 tap. Now, the one thing you may have to change, which doesn't seem to be the case usually, but the number of ineffective threads. This is going to change how much extra you go. So right here, you'll see we're going to 1.4. We should be clear through the part and be able to go to 1.4. But the reason we're going the extra 200 thousandths is because of the 4 ineffective threads, and a 1/4-20 is a 50 thou. So we're going an extra, the pitch is 50 thou. So we're going an extra 200 thousandths. So yeah, you definitely got to make sure you got the right number of ineffective threads, and then make sure you drill the right hole. I've seen it before where it does have the drill going to a certain depth and the tap is either clear through where it way deeper than it needs to go, or it's right at the level where it catches on the on the tip of the drill, the tip that the drill left in there. So, which might be a problem with one of the guys I know of. I'll talk to him. All right. So again, make sure you have the clearance. Taps are the biggest thing. I would always say double check that Bobcat got it right. We're clear through on this one, and we want to go all the way through with it. So we kind of got to go that far. So when we're all done, we can hit compute, and that's just going to show us some drilled holes. There we go. There they are. Oh, and actually, hold on. We didn't even set our top right. Let's look at this. So we're going 1.2, but that's from the top of feature of 0. If I pick top and I pick that point there, we're actually minus 100 thousandths. So going 1.2 is still good. We'll be fine. That's what I was thinking we were doing anyway. So I'll keep it there. All right. Oh, so you can see it now. There's our center drill, our drill, and our tap. All right, let's knock out the, let's do this. We could do the center hole here. I did not set up a drill for that. We're gonna spiral in. All right, so we're gonna do a mill 2 axis. This is gonna be a pocket. I would usually say drill a hole in here first and feed your tool down that. That'd probably give you a better result. But I didn't pick a drill, so depth we're gonna go first. First, we're gonna pick the right top apart. There we go. And then we're going to say the bottom is going to go, this is all the way through. So again, we'll go 1.2 deep. All right. Next, we have our feature. So we got our top of feature, total depth. That's great. No extensions. This is just a 1-inch circle. Next, again, we're going to do some pocketing on this, which will give us a pocket with the profile finish. Now, if you're okay using the 1/4 inch on this one, I would recommend using it. That way we can copy and paste these tool paths to the other places we need. Not a bad idea. All right, right here's our tabs. We're not going to leave any tabs on an internal hole. The posting, work offset 1, that's really all we need. And then the roughing tool. So we're going to choose I'm going to use the 1/2 inch right there, 1/2 inch flat. And then go next. And for this one, I want to do let's do it as a, spiral pocket, but I'm going to set it to like, let's do an adaptive. Yeah, adaptive will do about the same. We'll do it at a 10% step over. Let's see, 5%, because I'm plunging into this thing. And so I'm doing this with a really fine step over. I'm going to spiral my way down into the pocket. And then I'm going to let it kind of do that high speed adaptive roughing. So let's go 7%. There we go. All right, so the side allowance I'm going to leave for the 1/4 inch finisher is going to be 15 thousandths. So it's going to be cleaning up 15 thousandths at 1.2 deep. It's as long as my flutes. So let's do this. Let's go, instead of saving 15, let's leave 10. Now for the bottom allowance, 0. The link clearance is the amount that we lift up when we do our retracts. We shouldn't have many of those. I think this will pretty much just be a spiral. So 20 thousandths is fine. And then for the multiple steps, I want to do, let's say, a 1/2 inch at a time. So the way that we can do this is you could say define depths, and you can define specifically a 1/2 inch. Now what that's going to do is it's going to break it down into 3 passes. The first one at a 1/2 inch, the second one at 1 inch, and the final pass will be at 1.2. So your final pass is just cleaning up whatever's left over. If you ever do T-cutters, through doing T-cutters in a slot, that's a way to get an odd, or a T-cutter that doesn't match your slot perfectly. That's how you can get it to fit it better. There's other reasons too. All right, so for the entry, how do we get in? We're going to plunge, we're going to ramp, or we're going to spiral. I want to do a spiral, and we probably will end up changing this number. It's a 1-inch pocket. We'll see. So we'll go ahead and go next. The machine sequence, I always do optimized. This part only has one hole right now, so that's all that matters. Right here's our links, no changes. Advanced feed rates, no changes. And then Oh, right here. Sorry, there is a change we could make. The adaptive feed rates. You only get these two options when you're using the adaptive roughing. And so the adaptive or volume based, you can have your feed rates speed up or slow down based on the amount of engagement. Now, we should have a pretty consistent engagement when we're doing this spiral. So this wouldn't be a bad idea. You could also do radial chip thinning. And the goal of this one is to speed up and slow down to get the correct size chip coming off the tool every time. And you define it by saying my minimum feed rate is down to 75% of my feed rate, and the maximum it's allowed to go is 125%, whatever you want to put in. But this one should be pretty consistent, and we're cutting it at 230 inches a minute because of its aluminum carbide. Yeah, it's got some quick ones. It's the feed per tooth. It's a 4 flute. Yeah, we'll see. And then next, well, you can. I mean, 230 is not impossible. 1/2 inch deep could be a little bit crazier. All right, so we want to go with our 1/4 inch flat end mill long here. And again, the reason I'm using something like this is because it's going to be used again. I'm going to use it on all the other ones. So now I could copy and paste this tool path, and I don't have to run the adaptive every time. I could, but I don't have to. So right here we have our compensation. So I could say machine compensation, and I'm going to go with the G41. That way Bobcat is compensating me for a 1/4 inch tool, but in the code I'll have that G41. So at the machine I can do my own compensation to if I got an undersized tool or something. If you're not using your G41s, definitely read up about them. They will save you lots of time. Most of you guys probably are, but I met quite a few guys who don't use G41s, and they go back to Bobcat. If they made it for a 1/4 inch tool and then they walk out to the machine and their tool's undersized, they go back to Bobcat, they change the tool, repost the code, bring it back out, and they run it that way. And or you could just use your wear offsets in the machine with a G41 and call it a day. So that's what I recommend. If you don't know about it, read about it. You could probably look up some of the articles written by the guy that did GWizard, Bob. He writes some great articles about it. So check it out. All right, parameters. I'm going full depth on this. That's why I only left 10 thou on the last one. Total depth's 1.2. I want a nice clean wall. And we are going to do spring passes on this, but I don't make multiple profile finishes if they're just going to be the same profile finishes. So I'm just going to copy and paste this one when I'm done. So next, right here's our leads. We're going to plunge in vertically. Just kidding. We're going to do a right angle. And the easiest method to do this, we know it's a 1 inch arc. So 1 inch. Whoops, let me click in the correct box. We know it's a 1 inch arc. We're going to subtract the tool diameter, so 0.25. So we're left with 0.75. And then we're going to divide that number in half. And the result is going to put our tool right down the center of that hole. It's then going to feed over, make the cut, and we got the lead out going same as lead in, so it'll feed back out, come back out the middle. We are going to copy and paste it, so it will retract and move a couple times. It does waste a little bit of time. Yeah, because it's going to feed back up and then it's going to enter right back in. But it'll retract back to the rapid plane and then feed back down because there is no way to do the exact same path. Unless you did side roughing. Yeah, forget about it. We'll do it this way. All right, so next we then have our corner types. Not an option I mess with. I'm going to leave that on sharp. And when you're doing this, it just pretty much think of it as it's following whatever geometry you have drawn. So sharp corners, round corners, that stuff doesn't really, it changes the way that the tool runs around it. So, all right, so we'll go there. We'll go next for the machine sequencing, optimized, sure. And the advanced feed rates, no changes. And we'll hit compute and we'll see what it looks like. Not bad overall. Let's go to a top view. So the big thing you want to kind of pay attention to when you're looking at this, if your spiral, which for us is right down the middle, which is a beauty, sometimes it'll offset the spiral depending on the shape of the pocket. Round pockets, it tries to go in the middle. But what you want to pay attention to is sometimes if that spiral, and let me blank this out so we're looking at just that rough pass. If the spiral ever goes outside of this furthest out line, you are going to plunge into your material that you didn't want. You're going to be running into, well, you'd be running into that wall there and doing a divot. So that's where you might have to, and I wasn't sure what it would take, but that's where you might have to go to your leads and make your ramp length smaller. Or, go to a different, or ramp in, I don't know, whatever you got to do. There we go. So that looks good. We got our 3 passes. So there's our half, and then the extra 200 thousandths. Then we have our profile finish pass. And then to hopefully account for some of the potential, what's it called? Shifting of the tool. I'm going to copy the profile finish. And I'm just going to go ahead and paste it right below that. So paste. And then paste. And we'll say we're doing 3 spring passes. So we'll compute that, or 3 finish passes. And there we go. Blank those guys out and shrink it up. Now this one I'd right click on and say rename and just call this center through hole. And there we go. Now it's named and we have it. All right, so we've done those 2. Now we can actually take the center through hole that we just made, and we're going to go ahead and copy that. And we're going to right click on machine setup 1 and paste that feature. It'll say, do you want to use the same top and depth? Yes, I do. I'm not actually going to go 1 inch through with these though. So I'm going to start by just renaming it so I know which one I'm working on. And this is just going to be my, I call them slots, but I'll call them slots because that's what I called it on the layers, but really these should just be pockets. All right, so the geometry for these, we'll right click, say reselect. We're going to hold shift and pick all 6 of them right here. And then right here, we're just going to change our depth to 0.375. And then hit OK. Now, if you want to use the same pattern, this should have changed to a single step. So if the tool fits, we could run the same tool path, or we could just go into our patterns here and just say, I just want to do an offset pocket out, and I'll go with a 25, 30% step over. And we could still spiral in because we didn't drill any holes into this. And again, if you don't want all the spring passes, you could actually come into the machine strategy page and get rid of them. I'm going to leave them, and then I'm just going to hit compute. Now, what we want to pay attention to with this one is the leads for that final finish pass. We should be safe, though. Did I accidentally turn off spiral? Okay, so the spiral doesn't fit in here at that size. Did V34 correct that for me? Maybe it did. The tool paths may be getting smarter and I didn't realize it. I have spiral on that feature and it ramped in. Got our little entry there. I'll have to ask him about that. If it does, that's pretty cool. We don't have a lot happening there. Let me edit this. Looks like a kind of heavy step over. Let's just go to 20%, see if we get at least 2 passes with that. There we go. Now we got a little one on the inside. And then there's our profile finish out there. Again, what you're looking at with these leads, and let's look at them from a top view, is making sure they don't overlap that final pass. Let me blank these out. They don't overlap this final pass at all. If they do, you're going to gouge. Which it doesn't happen too often, but sometimes it gets pretty close sometimes. We do have allowance on there still, so it's not the end of the world. And then for these ones, I didn't do any of the calculations. This should be, I think it's 1.5. I don't remember. Let me look. from here to here. And then if I measure that, or 0.75. So what we'd have to do is for our distance across, if we want to do the leads for the profile finish to come right down in the center, we could do the same kind of math. So 0.75 minus 0.25. That leaves us with 0.5. We just divide that by 2. Compute. And then that should be plunging right down the center of that pocket. What I now have to do is go to the leads on that profile finish and say apply to all operations so that it copies it to these other leads pages. It shouldn't do anything to this one, though. Oh, it did. I got it back to my spiral. Oh, yeah, leads has plunge. Okay. All right, and just compute, and that'll fix them all. All right, so we'll go ahead and shrink that one up. And what is it? 11:42. We got plenty of time to finish out this. Let's do this inside pocket here, or the counter bore. I'm just going to copy the same pocket, paste that feature. Do you wish to load the same? Yes. And then this is going to be renamed just C-bore. Whoops. And then we're just going to pick our geometry. Now, we could go in, and if we were to make this center hole a dotted line, we could use it as a, open pocket. But really, this thing's, it's 1 1/4. We're going an 1/8 inch deep with that. And we're just going to go ahead and hit OK. Again, the only change I'm going to make on this one is the profile finish leads. Whoops. Edit that. So again, you go hole diameter minus tool diameter and divide it by 2. All right, so let's just do that. Again, I'll just say apply to all operations, and then this time remember to go to my leads and turn that back on to, actually, we can plunge this one. We've already cleared out that big center. Yeah, we'll just plunge this one and compute. So there it is. Plunges down, spirals out, running right down the center. So the counter bore is now done. All right, easy peasy. Let me get rid of that last piece of geometry I don't need. And so this last one, what we're going to do is we're going to calculate one of these, and then we're going to do a toolpath pattern with it. All right, we're going to try. I haven't done it with this part, but it shouldn't be difficult at all. All right, so for this one, instead of doing the full cut around, which I definitely would, I want to just use this radius around to this radius, or whichever one. We'll do the top one and then rotate it from there. But I just want to use that as my geometry. So I'm going to right click and go to my mill 2 axis, select my geometry. Now this is a big one. When we go to pick the geometry, let's go ahead and zoom into it, just like that right there, we'll say. And when you click the geometry, you're going to start at this first radius. The spot you're going to click it is, if this is the beginning, we're going to go past the middle and click the end. Thank you. From there, we're going to follow that chain all the way to the end to this final radius. You don't actually have to follow the chain. You could just jump over to it. But we want to go to the final radius, find the midpoint, and then go past it a little bit. You don't need to be right at the end. About 3/4 of the way down the line is perfect. Then we're going to hold shift and click. And that's going to chain all those geometries in between together. And that's why having that clean up optimize is super important. You want clean geometry. Now, let me just show you what happens if you pick it the wrong way. If I click it this way, and then I click it on the wrong side, it'll chain everything but that. All right. So let me clear that out. First radius, final radius. We got our chain going in the direction we want, because you got to think we're always thinking cut to the left. Our compensation's to the left for a climb mill. So to the left of that arrow puts us outside the part. That's what we want. So total depth, this is going to go we'll do the 1.2. Again, we're ignoring how we're holding this part as of right now. It's fake because I didn't plan that yet. All right, so I'll hit OK. And then I'll go next right there. So we have our depth. Top of feature we want to go in. We'll say pick top right there. Hit OK. And yeah, there we go, 1.2. Now, you could do extensions on here, and it will extend the geometry. You can do a certain distance, but you got to think we're going from that radius into an arc. So we kind of want to end that chain and get out of there as fast as possible before we kind of arc around. So we're not going to do extensions because that would kind of send it on a straight path. And we're going to go in and then right out with a circular lead. So the machining strategy is a profile rough and a profile finish. Perfect. Right here we have our tabs. We're not going to leave any tabs, not in an open cut like that. Our posting, just work offset number 1. We're not using contour ramping, but this does affect whether or not we output it with lines or arcs. Not important right now, sorry. And then right here, we're going to pick our tool. Going to use our 1/2 inch flat. Go next. Now for the patterns on this one, we're going to just do some side roughing. And we can go in and do we could either tell the system how much stock is remaining and how many passes we want to use to take that out. Or we could tell it the step over. And, I like the step over because I could define exactly what I want. So the step over, we'll say we'll take out, let's see, we'll go with like a 25%. So we'll say 0.5 divided by 0.25, right? That's the wrong way. I want 20% of 0.5, 0.1, sorry, 0.1. And we'll do that we'll say 3 passes. So it'll offset us out, and we might need more. I mean, we could probably go bigger on our step over, but we could base it on that. Then we have the choice of doing a zig and just making a cut, going back to the beginning and making another cut, or doing a zigzag, which is a climb conventional. I'm going to go with a zig, and we'll wrap it back to the beginning. For the compensation, I'm not going to comp this one unless my tool is really undersized. I really don't worry about it with the rough pass. The finish pass should be able to take care of it. And then our linking is going to be direct. We could also do an S-link. The difference is if we do an S-link, it's going to leave with a tangent lead to the next link. It's your linking between your 2 passes there. So it's what happens, how do we get there? That should be good enough, I think. All right, so the side allowance, once again, I'll just leave, we'll say 10 thou, and then we'll do this in multiple steps. We'll do it 600 thousandths per pass. For the leads, I'm going to go with a circular lead, but I want to go with a tangent for the lead out. So it's not going to circle back around. It's going to should hopefully go straight out and into that cut. And we'll find out. All right, so we'll go next right there. Corner types, no changes. Machine sequencing, optimized, next again. Advanced feeds, no changes there. And finally, the finish pass, we're going to use the 1/4 inch tool right there. And this one's going to be just comped G41 parameters. We'll do it we'll say single step for now. And then I do want to just jump up to my leads, say apply that to all operations so it gets all the same leads. Maybe I go length 3/8, yeah, that should be fine. Corner types, no changes. Sequencing, optimized. And advanced feeds. So we'll then get to hit compute. And that's what it's going to look like. And honestly, we're probably cutting we're cutting a bit of air there. So let me save this real fast. And let's just look at our stock. So that's what we're taking out. Let me turn that on for good. Actually, let me change one thing. The transparency. I want a higher transparency. Hey, that's better. So now I can click on this. So this is our profile rough. So we have our first pass. Oh, there we go. We have our first pass here, second pass there, third pass there, then the finish pass should be that last one. So those are those 3 passes. We could probably do a little bit bigger, but that doesn't look bad. We're not wasting too much time there. And then we have our profile. Whoops, I switched the order of those. And then we have our profile finish there. So hopefully this will work. And we could also go in and potentially add we might do a different lead on that. We'll see what finish we get out of it. We'll see. Maybe do a blend. That might work. I don't know. All right. Compute, and we'll say outside cuts, rename, outside cuts, and there we have it. All right, so now what we're going to do is we're going to right click on that feature and say add a toolpath pattern. All right, so again, you're going to right click on the outside cuts feature we just made and add a toolpath pattern. From here, we can do an array, we could do a translation, we could do a rotation, or we could go and pick points and tell it where we want them to be. We're going to go with the rotation option and go next. And then we're not using the 3D option, so all we have to do is tell it the angle, which there's 6 of them, so it's always going to be 360 divided by the number, so 6. And then the total copies, just like the copies when we did them earlier, 5. You're accounting for the one you have. Now our rotation axis is XYZ 0. This is another reason why I like to draw parts right on XYZ 0, because then I don't have to change anything. 1 second, I got to take a drink. And then we can go ahead and hit OK. And if we unblank that feature, we should now see that outside there. So let me hide my stock once again. And there we have it. So we're about to break for lunch, but let's go ahead and give this a save. And then we'll go ahead and say start simulation, and we can see how it comes out. What? All right, let me just restart my Bobcad. David said, so for the slots, if you shorten the ramp radius, would it have spiraled in instead of ramping? Probably. We could try it real quick and see what result we get. But yeah, that sounds like what I would imagine would happen, because there's times that when I've done, I usually use spirals more on circular pockets anyway. But it seems like a lot of times when you're doing a spiral on the circular pocket, it depends on what kind of pocket you're using, I think, too. Like an adaptive might be able to handle it better. Let me open that part back up. Let's see. So I think I was at a 1/4 inch on those. So we want the slots, edit. We want the leads, and we'll do, oh no, this leads, my bad. There, one. And if we made this, let's say just a 1/16, just go even crazier than we should. Yes, absolutely. So yeah, if you were to go like a 1/16 or something, that would spiral down and it would work. Good question. All right, so I'll save that. I don't mind that. Something's going on with my simulation. There we go. That's what I need. All right, so this one's going to start with the face off. Do I have my, yeah, there we go. So I'll slow it down a little bit. The facing sometimes runs pretty quick. We could speed it up from there. There we go. All right, so we're going to face it off first. I'm just going to hide the toolpath. There we go. Center drill. We should see, we'll wait till we're done. There's our spiral down, and then we're going to open it up when we get down to there. There's that 200 thousandths. Here's going to be my little spring passes. There's my 1/16 inch pockets. Man, it's cruising. I can't keep up. Right in the middle. There we go. So there's that spiral down. That's the new 1/16. Or we could have kept it at that ramp. That's what we would have tried. When do the toolpath pattern, it seems to go wide on the other. Any reason why that? Are you talking about in the simulation, Brock? Sorry. Are you talking about, yeah, with these, or is it just when you see them rotated? It could be if you're, let me see. If it's in the simulation, I'll catch it right now. No, when it's calculated. Okay. Is your part drawn? I sent you my part, so it should be drawn in the center. The origin was in the right spot. Did you change? So if you right click on your toolpath pattern, rotate right here under outside cuts or whatever you named it and go to edit, you got 60 with 5 and then 0, 0 right there, right? All right, mine looks, I'm happy with that. All right, so I'm trying to think of what could be different. So on these outside cuts, they look like this, but they seem wider. Is what you said? Oh wait, you're on the, so wait, are you talking about this? Give me 1 second. Let me do this. Is it like that? Dang it. Yes, and not on center. Like outside the stock. Let me fix this. Okay, so you didn't get my part file because you couldn't get into your email. Okay, so is your part not drawn on center? Like at XYZ0 like mine? It is on center. And you have just that picked for your geometry. Huh. And you can't get into your email. Dang it. I was going to say email me your part during, because we're about to take lunch, so you could email me your part and I could look at it real quick and find out what's going on. If you want to do that, because I don't know if your toolpath pattern, so you got your, does the original toolpath look good? And then you did your toolpath pattern. Hold on. So you did your toolpath pattern and you definitely picked rotate, right? I'm going to start with the most basics. Yes, got it. Hold on. I got to delete these extra yeses because I'm going to get confused on the next question. All right. So right here. So then you got 60 for your angle, 5 copies, and 0, 0. What was the question? This is, I mean, you're in the rotate command, right? Like I'm starting at the basics. You went to rotate. You didn't do array or something. Okay, good. And then on this page, it should just be 6. Yeah, email it to me. You should be able to just do training@bobcad.com. And it should come to me. But if I don't get it in the next little while, I'll talk to you on here when we start back up. We're gonna go for another, hour and a half, 2 hours after. I got to figure out what we're gonna do, but we'll look at your part and see what kind of problem we're having with it. I don't know what it could be. So, all right. Talk to you guys in 1 hour. That's when we'll come back. There we go. All right. So David sent a couple pictures. I got a couple questions I'll go through here in a second. So give me 1 sec. Let's wait on that one, David, and I'll do it in a few minutes. We'll get through this. So first things first, Brock, are you back? Are you here? Are you watching? I need to make sure he sees it. Yes, perfect. All right, so right here is your part file. Now, I just want to show you my part file, and I want to point out one thing. When I have my stock on and I look at my origin, mine's top dead center. Yours is right over here. So that's what you'll see. Your machine setup is right there, which is totally fine. The adjustment we have to make is on the toolpath pattern. When we're on here, mine is going off the origin of the part, and the origin for my part is the center of the part. So it's XYZ0. Yours, what we're going to do is just hover over this arc in the middle, then pick that center point. And what you'll see the difference is you have a Y that shifts your rotation center point up 3 inches to the center of the part. And then if I hit OK, it fixes it all. So that was the only difference, and which is totally fine. That might be where you set your origin up. If that's not where you wanted to set your origin up, you'd have to go right-click on Machine Setup 1 and say Edit, and then you'd have to pick this top dead center point here. Now, I'm going to do this. If you meant to do it, that's great. If not, we'll fix it here. Now, for everyone else who's seeing this, think of this as if you accidentally put your origin in the wrong place when you started and then you made all your tool paths, which happens. I've done it a bunch of times. Or it's one of those things you're thinking, I'm going to use the bottom left corner. And then when you get it set up on the machine, you realize it's easier to find a different corner or whatever. So if I move this, right now, all of the tool path that's in the part is in accordance to where the original origin was. So now that we've moved it, you'll see the tool paths moved along with it. So what we have to do is we have to right click on milling job and then just do update all geometries. And then we're going to right click on milling job again and then hit compute. And it should just recalculate all those bits of code. All right. And now, because we have our toolpath pattern, the toolpath pattern now has to relearn the position, or we just have to reset it. Right now, what's happening is it's rotating it about a center point right out here. And from our one toolpath, it's just basically spinning around itself. So we just have to edit that, whoops, not insert, just have to edit that toolpath pattern and just say pick. And once again, just pick the center of your geometry. You don't have to worry about Z because it's the center of the geometry. It's for X and Y. So now I can hit OK, and that's going to set it up. Now, the next thing I always would say, if you do make this mistake, go in and check the holes afterwards. Open up, especially your tapped ones, open up your feature because it likes to do this shift of the top of the part. And we went with Brock's copy. He had his origin on the bottom of the part, which is common for if you're doing this on like a spoil board where you'd be setting your part down and either vacuuming it down or clamping it down somehow, screwing it down, whatever. You'd go off the spoil board and then your heights are up from there. So we'd have to go in and say, well, the top, we'd say pick top. And then this always does this. All right. And then pick just any edge that represents the top. And then right here, we have to reset that depth. So we'll go 1.2, just like that. And then when you go back and look, your parameters should update for your drills and everything like that. So now I can compute that. That's really the only one you'll have to worry about the depths on. And a lot of it comes from the fact that we're using wireframe geometry to define our holes. If we had a solid model and we picked the inner surfaces of the solid model holes, then when we say reselect geometry, it reads the diameter and the depth from that. So the odds of it not making a mistake doing it that way are better. But you'll always have to double check the holes just because especially when the origin changes Z positions, it can act kind of weird. So there we go. All right, Brock, did you get all that? It was your origin was in a different spot. That's all it was. All right. Awesome. All right, so Brock's got that. Let me get rid of this. Just got to clean up the chat so I can see which one I'm on. Sent you the file. Got it. All right. So, got it. All right, so John, you asked, can you explain how to look at the views top, bottom, and apply dimensions to them? Yes, we could totally talk about that. So, let me grab this right here. All right, so I have my stock turned on. Let me hide all that stuff. Hide that. There we go. So the top view is this view right here. It's just when you click this button. Now, this is the top view of the top UCS. And the UCS is really what we're talking about if we were to try and dimension in kind of different views. And I'll show you an example of that. So the top view dimensioning is really just whatever kind of dimensions you want to put on your part. I would usually do it. I mean, you're going to use the evaluate tab. And ever since they added this auto command, that's pretty much what I use. So with dimensioning in a top view, which is your standard view, but what the difference is going to be, if I'm in a top view, I'm dimensioning the top. A top UCS. If I was to go to a front UCS, that's looking at the part from a front view. So we're going to go right here and view front. And so all you're going to see is a line. And this is normal because we don't have any, the pockets aren't showing. We don't have a solid model to even like get a cross section of or whatever. So the front view is going to allow you to measure, I'd be able to measure the diameter of our part from like here over to here. And it's going to tell me that it's 6 inches. All right, now I'll hit OK and cancel. And then I'll go back to a top view. And so you'd be able to take your measurements based on whatever UCS you're in. So this, basically the UCS just rotates where you're drawing. So for dimensioning, it just rotates where you're dimensioning. In a part like this, you'd never dimension with that dimension. You dimension everything from the top plane. And basically you just want to align your X and Y axis with your part and then lay down dimensions. For something like this, I would... a lot of this is arcs, so I can pick this arc out here, and it'll tell me what the radius is. So I could do that. If I want to get the diameter, I could pick, let me clear out the geometry. If I wanted to get the diameter of that, I'd pick across those 2 points and get my diameter. Any arcs, you just have to click on the arc, and it'll give you the radius from the center point to that arc. If you want it to show the diameter, you really would have to measure across it like I did with the 6 right there. But fillets, you just click on the fillet. Again, I'm under just the auto dimension here. You just click on the fillet right there. You can see there's a decimal section. You could go out as many places as you want. For something like this, it's an 1/8 inch. So I would at least go 3 on there and then lay it down. For holes, you just pick the hole and it will define the diameter of the hole. I'll go right there with that. Same thing with holes. I don't really have any lines on here. Oh, I do. Here, if you want to measure like a line, you could just click the full line and then you can drag it whichever direction you want to take the measurement for. So lines do have some play with them that you can do. You could even dimension points. So you're just really laying down dimensions. Bobcat is not my first choice in making dimensions and doing like a print. It's possible, but you really have to, like with SolidWorks, to make a drawing, you bring your solid model in, and then you take your solid model and you say, I want to make a drawing out of this, and it brings in the views. You just say, I want a top, front, side, whatever. And it kind of does it automatically. For Bobcat, you'd have to draw that all out. And the way I would do it would be with I would still do it with a solid model, but I would copy and basically copy and paste that solid model. I'd have to rotate it, and it's a bit more work. It's definitely doable, but it's it can be a lot of work. So, did that answer your question, John? I could go maybe a little deeper. I just need to know where you want to be. All right. Well, he's answering that. So David sent me an email. He's got some parts he's working on. He doesn't have Bob Art, which is unfortunate. It's a fun little program to use. And the parts are for a radiator grill spar from a 1934 Cadillac. I like it. All right, so I saved some pictures of it. Let me open these up. All right, so give it a second and it'll open. So this is a part with a little, with a ruler, something next to it, and take some measurements. And he's asking kind of any ideas on how to do that. So Bob Art would be a good idea. But really, I would probably go with a known size piece of graph paper. What are you doing? You're trying to dimension a 3D file, John? Yeah, if it's 3D, you'll have to use those UCSs to get your different dimensions. So yeah, I mean, you could use a piece of graph paper, especially he said the tolerance isn't super critical. And then basically transfer those points that you come up with into Bobcat. It would be tough. I've actually done that method with a gasket that I was working on. I was working with a customer who was doing a stamp, essentially. Just needed to make a little stamp. They make these gaskets every couple years for one company for some snow equipment. And so they needed every once in a while. He didn't feel like making them anymore, so he was just making a stamp for them to make their own. But he didn't have any sort of, he just knew the shape of it. So what we had him do is I had him mail me the stamp or mail me the gasket. And then I got a piece of I think it was 1/4 inch divided square paper, graph paper. And then I just traced it with a real fine tipped pen and plugged it in. And then we were able to use that geometry. I brought it in, I drew everything out, cleaned everything up. And then we cut a stamp with we just basically used a V-bit and had it come to a point. And then, yeah, it was a big steel gasket punch, essentially, that the way he ended up working it out is he got it hardened. They set it on a gasket, smack it with a hammer, and that was as easy as they needed to go. It was quick and easy. I mean, for the longest time, they were just cutting a gasket by hand, but this is, it was a bit easier, but that's how we did it. Or another very easy way, but it would cost a little bit of money. It'd be the Bob Art. I know you said that in your email, but Bob Art would allow you to take this, and what's really nice is you can have a scaled drawing because a piece of paper is 8.5 by 11. So you could put it on a nice, clean white sheet of paper. Again, get a fine tooth pen or a real thick, heavy Sharpie, and you just trace around it real clean. And then you'd be able to scale that, or you'd be able to scan that drawing in. And because it's on an 8.5 by 11, it has a size. It's to the right scale. And I've actually done that a couple of times with a few companies that are just, the one of them was just trying to create storage boxes out of foam to put nuts and bolts in for a whole kit that they sell. So they were just milling out pockets that fit the shape of the parts that needed to go in there. But the kid that got stuck doing it wasn't part of engineering. He was just some shipping kid. And so they didn't let him have any of the drawings. They wouldn't give him the drawings of the parts to pull the wireframe from. So he was literally just any part that fit on a sheet of paper, we'd set it down, trace around it, and then Bob Art it and knock those tool paths out. So that would be a good one. That would be a great one for something like that. But otherwise, graph paper and then plot out points. And then this whole edge, unless that's kind of like an oval, like if you were to take another one and pair it up to the other side, would it make an oval? You know, if you flip-flopped it and mirrored it, would it oval? That could work too. If it was one big oval that just had 2 cuts in it, that gave you 2 of those. But it's different sizes, isn't it? Or are they all the same? Oh, here's the other pictures. You guys can see what it goes on. How do you go to the next picture? There we go. That's what it goes on. So they are all the same size. And so they're the ones down there. Okay. Yeah, I mean, any of those ways would work. But yeah, I mean, if we want to try it just to see if the Bobbard idea would work, can you adjust the spline to adjust? Adjusting splines is I think it's possible, but it's not super. Let's see. So we'll make like a smooth curve, as smooth as I'm getting right now. All right, so there it is. There's my spline. Now adjusting splines is a bit difficult because normally what you'd adjust with would be like the deform, or really the deform is what you'd get. And I don't know. Yeah, I guess you can adjust it. It just depends on where you click on it. And it affects kind of all the points around it. So it's not just affecting one point. It would affect kind of all the points around it. But yeah, you could definitely drag it and move things. So it's definitely something you could do. You know, I would almost look at putting two of them together, because if there's two of them together and you could get a full oval, you could just do an ellipse. Like if two of those put together made an ellipse, you would measure the X, you'd measure the Y, and all you'd have to do is punch those in. So looking at the picture again, let me open this up. You know, looking at that, if that was to come around and keep sweeping, let's call it 5 and, what is that? 5 and 16/64 ish. What's that break down to? 5 1/4. All right, so we'll go 5 1/4 on the, well, that would be our minor axis, so 5.25. And so that would be the minor, and then the major would be almost, yeah, if it looks like an oval, I would take a measurement of it straight across. Now, he said he did put the two together and it looks like an oval. I would do two straight across right now. If it's 10 inches or whatever, that would be kind of your oval right there. And that might work decently well. And then from there, you could either break it into arcs, or when you create an ellipse, you create a spline. So, I mean, you'd have to figure out your break point, where you want to cut it and where you want to cut it. But other than that, you'd be able to go in and do your deform and modify it as needed. All right. Cool. Yeah, that's probably how they made it. They probably made oval pieces and then cut them. They had a little thing, because you get, you know, two parts out of one oval. Or they just did it one at a time. I don't know. All right, so back to here. Did I answer everyone's question? Let's see. All right, so David, I got you. Yeah, that should work. I mean, it depends on your tolerances. John, I helped you. All right, cool. So I think I got everyone. If you guys have any questions, feel free to throw them in. This is a good one. All right, so did we finish this? Yes, we finished this whole thing. So I'm going to simulate it real quick. I think, did we simulate it at the end of the? I can't remember. I'm just kidding. I remember. We totally did it. All right. So we'll run through this pretty quick. All right. Part looks good. So now what I want to go and do is the pockets. I want to face it. I want to do the pockets, and I want to do the counter bore on the other side. So it's the same. I know a lot of guys struggle with this. It is kind of a goofy one, and we do have to be pretty accurate with this, because the holes are not. Yeah, the holes in the center. We need to make sure everything lines up. I guess we're not drilling the hole, so it shouldn't matter too much. So the big thing to do here is, well, first we're going to add our new machine setup. We're going to add another machine setup to the job. And we're going to do that just by right-clicking on milling job here. Excuse me. And then we're going to go down to add setup. 1 second, guys. I got to take a drink. All right. So we've added machine setup 2 in. And the big thing here is we're going to flip the part over. The stock that we have is already fine. We're going to use that same stock. We're going to copy and paste all the tool paths. But we have to make sure, especially if we were, not that we would, but if we needed to drill the holes in that specific location and everything, we just need to make sure that when we flip our part over, we, at the machine later on, flip it the same way, especially with that hole pattern being off. Because if I rotate across the y-axis, the hole switches spots. So it's just knowing which way you did it. Really, it's not that important. For us right now, we're just going to grab it. I'm going to go over the x-axis. So I'm going to flip it this way. All right. Or if we go control, there's a bottom view on here. How does the bottom view do it? So yes, so we could basically just go to a bottom view, and that's going to be exactly what we want. So it's just click that drop down and then that button right there, or it's Control 4. So Control and the number 4 above your keyboard will give you that bottom view. And then from there, I'm also going to tweak it a little bit so that it's like this. Remember, you can rotate just by clicking that middle mouse wheel in. You do not have to use the buttons up top. Just click your middle mouse wheel like a button, hold it down, and move your mouse. It'll save you a lot of time. So I'm basically setting up the stock, doing the machine setup again. So we're going to try it. Or we're going to do it. This isn't a try. This is easy. All right. So we first have to, we've defined machine setup 1. We now have to define machine setup 2. And without having a solid model and without moving any of our geometry, we need to make sure that we set this all up correctly. Our copy and pastes and our faces and stuff, because the face does it automatically, might not read correctly. So we're going to go in here and say rename. Actually, it should, because we defined the bottom geometry as the face. So I don't know. I didn't mean to say rename. We're going to go to edit in here. Sorry about that. Right there. And we're just going to pick the origin as this bottom point right here, the top dead center in there. You can pick whatever point you want. Just remember, there's certain things that rely on knowing where that point is. One of them being the toolpath pattern, which we don't really have to add right now unless we wanted to do that to the pocket. But the next thing we need to do is that Z, that blue arrow, always needs to be facing away from your geometry that you're trying to cut. The direction it's pointing in, you're always cutting opposite that, because that's kind of the floor and you're going into it. So we need to fix X or Y. Now, right now, X looks like it's pointing in the right direction. So I want to go right over here to the Y direction box, and these buttons on the end are just to flip the geometry, or just to flip the origin. So I'm going to flip that button right there with the Y, and then I'm going to flip the button for the X. Or if I did that the other way, it would have been like that. If I had just flipped my X, same thing. We got to flip it either way. So X and then Y, or Y and then X doesn't seem to give you a different result. They both need to be flipped. But don't pay attention to the Z. Only pay attention to the X and Y. We have to follow the right-hand rule in Bobcat. So what that means is we can never violate that. So if you get X and Y in the right locations, pointing the right way, Z has to follow that. There's no other way for it to, we can't do a left-hand rule. So there it is. So now we'll go ahead and set up, if you wanted to change work offsets, you could. It wouldn't be a bad idea, if you had specific jaws made for this and they're taking into account now that the part is 100,000 smaller, you could go in and, let's say, work offset number 2. So that'll be a G55. So if I was doing a bunch of these parts, or maybe 2 at a time even, maybe I started on one vise, I flip it over and shove it in another vise, and now I'm running 2 ops or 2 parts at the same time, a rough on the top side and a finish on the bottom side, and I'm just switching because we're going to use all the same tools, so it wouldn't be a bad idea to do that. The only other change, again, I'm going to make is add a Z value into my work offset. Again, that's just for my simulation. That does not affect the code. So there you go. Clearance plane's fine. We'll hit OK. Now, with this one, because of when we define the stock, we added the end face and the start face. So it should know how much geometry we have. I was thinking it might look at it based on where it touches geometry from our origin. All we got to remember is we added 100 thousandths. We know where the top of the part is, and we know how we're going to run it. So you could either copy the feature, which is going to have the depth and everything. So we'll say copy. In V34, you also have copy with geometry. And this is helpful if the geometry stays the same. So I'm going to just say copy, or it doesn't. With facing, it doesn't really matter because it automatically finds it. So I'm going to go ahead and paste it there. Now, this is something new to version 34. And if you guys didn't know it, now you'll know it. When you copy and paste it in the past, so version 33 and back, if you copied a feature from machine setup 1 into machine setup 2, and machine setup 2 has G55 or work offset 2 running, the feature that you pasted would always stay as its original work offset. Now it can change that. It'll automatically change that if you want it to. So would you like to update machine setup 2? So basically we want to update the facing feature to match machine setup 2. So we'll go ahead and hit OK. We'll just say yes. And then if we right click on the facing and hit edit to double check that it worked, and just to show you guys, on the posting page of this now pasted toolpath, it's set to number 2. So that's how we got it. So now I can hit compute, and there it is. It looks pretty good. We want to look at the feature page here. Top of features at 0, which is perfect, and the total depth is 100,000. So it is recognizing it based on what you set up as the origin or the extra stock that you have on there. All right, sorry about that. My throat keeps drying out. All right, so we will compute. It's already there, and there we have it. So then I'll shrink that up and blank it out. Now we then want to do our counterboard pocket. So we're going to copy the, actually we'll do the slots first. That's the order we did it before. So we'll copy the slots. And we should be able to copy with geometry because from top side to bottom side, as long as everything's located properly, they should line up. So we will copy those. And then I'm going to paste them. We should be able to do actually copy with geometry. Let's try it. Let's see if everything lines up. So we'll say copy with geometry. Or if you have version 33, just copy it. What if you left these on the bottom of setup 2? So if you're saying, so instead of having the one on the top and this one floating up above the part, it's sitting down there at 0 there, Rick? I would edit machine setup 2. So right click on machine setup 2 and just go to the top, say edit. All those points should pop back up. Are you saying you did it unintentionally or you meant to do that? Because that could be different. You meant to. Then you would have to locate XY on this side of the part and then drop it down to where that Z0 would be. Or if it's locked in from, well, machine setup 1 would have been on top of the part. Well, then, okay, so on your facing, all right, let's see. you'll have different numbers than me. For me, I have 0, and you should have, if you're at the bottom of the part and you'd be up 1.1 inches. So your top of feature for your face would end up being a top of feature at 1.1 inches. And then your total depth would be 0.1, because you're going from that center point at the bottom, you'd be going up 1.1 inches to the top of the part, and then taking off your depth of 0.1. And then when you compute that, that should show your face in the right location. Let me know if that is what you meant. I think I got it. Without having a solid model with this, it does get a little bit more difficult. But a quick little button that you guys can learn about real fast, and it pays to know it at least, is the stock. When you're inside the stock. So what I'm going to do is over here in my layers, I'm going to add a new layer and call it stock. All right. So if I go over to my stock in the cam tree now, and I right click and go to the stock wizard, or actually, I don't even have to go there. Sorry. We're going to right click on the machine setup 1 and just say edit. There is an option in here called keep bounding geometry. And what it does is it grabs the wireframe that Bobcad created and it adds it to the part. So I could go in and say origin, or keep bounding geometry, cancel out of that. We didn't change anything. And then on that layer, I now have that bounding geometry. Why is my other stuff disappearing? I don't know how that happened. Something got moved. All right, no big deal. I'm just going to, let's make sure this is good. This is good. That's good. And then the base should be all the rest of that. Huh, that's really weird. It grabbed my base somehow, but that's a way to keep it. So now what you'd be able to do, because your origin, is at the bottom of that part, you'd be able to go up and inside your feature right here, you'd be able to go in and say pick top, and then you'd pick that point right there, and then you'd tell it the depth you wanted to go. So definitely doable. Just depends on, how you set your origin up. But really, how you set your origin up is, it's very important. But there's many ways to do it. You could really set it up off whatever you want. Wherever you can locate, you could pretty much mimic that in Bobcad and locate off of it. So let me pick this thing. Am I in a feature or something? What's going on? There we go. There we go. All right, so let me just move this back to my current layer. Then I can hide that stock. There we go. All right, so we have our facing on there. Yep, right there. And then we will now do these slots. So let's do this one. We're going to right click on the slot, say copy with geometry. If you're using version 30, I just said this a minute ago. I cut myself off in this one. If you're using version 33, just copy it and then paste it. All right. And I'll go ahead and paste the feature. And then what you're going to do, well, I'm going to update all my work offsets, but then what you're going to do if you have 33 is right click on the word geometry. There should be a little red plus sign because you guys don't have a copy with geometry. So you'll right click on geometry, say reselect, and then hold shift and pick all 6 of your pockets. And then when you're done, we should be able to, and if this works, let's go look at this. We'll say edit. We're at minus 0.1 for our top of feature and 0.375, exact same cuts on this side. And we'll go ahead and compute that one. And there we have it. There's our slots for that side. Man, it stinks not having a solid model for this. If someone wants to do the solid model, anyone give me a yes. And when we finish this, we'll draw out the solid model real quick. I'm going to do it anyway. Just to show you guys, it's just how easy it is, really. It really won't be too bad. All right, so we're just going to blank out the slots, shrink it up, And the next thing we're going to do is the counter bore, which I have right there. So the counter bore, the C bore there, we're going to copy that guy. Again, we could do it with geometry, or I'm just going to do it like we do it in 33 or 30. Copy it, paste it under machine setup 2. Do you wish to use the same top and depth? No, I'm going to pick it this time. I'll do it myself. So right here, we'd right click on geometry, say reselect, and we're just going to pick that counterboard feature once again. Now, right now, again, what it's doing is it's not accounting for the faced off material, and we have no geometry to pick that. So we have to remember to go and do our minus 0.1, and then we could tell it the total depth, which was 1/8 of an inch, so 0.125. And then we'll hit OK and compute that thing once again. And there it is. Perfect. I'm trying to think here. Yeah, that should do it. I was thinking if there was a cool way to show some stuff off, but never mind. All right, ignore that. So let's go ahead and give that a save. It's been a while. I haven't saved in a while, at least. We'll go ahead and shrink that up. And then looking at everything that we have on the part, we got the slots. Yeah, that should be everything. So if you go into and run your simulation at this point, so I'm just going to run the sim. It will flip the part over for you. So we should see the whole thing run and get the results of what the entire job is going to run like. So we'll start it right there. All right, so face off top, center drill, tap, open up that center hole, make our pockets, outsides, and then we're going to flip it over, face it off, make our other pockets, and make our counter bore. So now we have the entire part done. Everything lines up. Looks pretty good. So again, there's still the whole thing with, work holding we have to deal with that I didn't go into, but that's what makes you guys a machinist, right? So let me go ahead and close out of this now. So how would you go and post this out? All right. And this is totally up to you how you do it. And it really, it kind of is up to you, and it depends on your post as well. So the first thing you want to do is make sure you have the right post processor. I'm going to go ahead and just do a post yes, no on the entire jobs for now, just to show how it works with just the facing toolpaths, just because they're short and quick and we can look at them. So from here, I'm just going to post my code by right-clicking on milling job, or you can go up here and hit post. Don't matter how you get there, just get there. And so right here, we'll see we have machine setup 1, G54. Machine setup 2 down here, G55. So the way this post handles it is it puts an M00, it puts an optional stop in the machine for me to flip the part over, which is one way of doing it. Another way of doing it could be what I mentioned a few minutes ago. Maybe we run just machine setup 1 on a single part. So we'd post the code out. This is all the code for machine setup 1. We cut that part. We take that part out, we put it in another vise, and we then would run both of them. At the machine, we would locate G41 off of the first vise we used, G41, G54, and then we would use G55 on the other vise. And you'd post it all out, in which case you'd want to get rid of, well, it's way down in there. You'd want to get rid of that M00. Another way of doing it is you might cut all the tops and then flip it over and cut all the bottoms. That's another way of doing it. And for me, that would just be, you do a post yes, no on, let's start with machine setup 1. So you'd post yes, no, machine setup 1, you'd post it, you'd right click in here and do your save as, we'll call it that. And then we could call this, top, or I'm just going to go op 1, and then we'll say save. And then you would turn that one off, turn machine setup 2 back on, post the code, and then you'd be able to do a save as on that one. And we'll just say op 2, save. And so now you have 2 sets of code that you could bring out, and that's kind of really depends on how it's doing it. Brock, you're not able to post the code. Pushed all the post buttons, but it's not coming up. Is your post now? Posting should show up. What machine? Actually, I could see what you're using. You're using the BC3X mill. That's what you were using. Did you ever delete any posts? Do this right here in your cam tree. Right click on the post that's just below the BC3X mill. Right click on that and say edit. A box should pop up. You're going to hit select. And it should open to this folder, but if it doesn't, I'll walk you through where the folder is. You're going to go to your C drive here on the left, then to Bobcat Cam Data, and then whatever version you're using, version 33, 34, 32, whatever you got, open up that folder. In that folder, you'll then see one called Posts. We're going to open that one up. In that folder, you'll see the machine type, so we're going to go with mill, and then pick one of the posts out of here, like, repick the BC3X mill, and then hit OK, and then try and post again. If that doesn't work, I've had it happen before where you just won't post. Save your work, close Bobcat, open it back up, and try and post. Sometimes it's simple as just restarting the program. Usually happens to me if I let my computer go to sleep. Like when I go to lunch and my computer falls asleep, that's usually what I get. But try those out. If it's still not posting, if it's specifically this part that's not posting, then I'm not sure. All your options might be set to post yes, no. If these little things are lit up right here, or let me go to the classic view, cam, classic, apply, okay. The classic view would be these little icons right here. So next to your features, if you have that little controller with the X on it, that means they're post yes, no. You have to right click and do a post yes, no, just to turn them all back on. And then again, when you post, it should come up. If that doesn't fix it, we'll probably have to look at it, see what's going on, or get in touch with tech support, because that shouldn't happen. Because even on yours that you sent me, other than the changes I made, it's there. So it's either a bad connection with the post or something else. All right. So those are all the kind of different ways you'd be able to post that one. Now what I want to do, and it'll be pretty quick, is I want to make the solid for this. I figure I'm not going to wait. Let's put this all into one thing. It's still 2-axis cutting. It's just a little more 3D geometry, but it'll let me, you guys will see how much easier it could potentially be to make this part. So the first thing I want to do is I want to make a layer and call it solid. Whoops. But I also want to make another layer, and I'm going to call this layer bottom. And this is just going to be the geometry that has to cut through the bottom. All right. And so the way I'm going to set this up for the bottom pieces of geometry is with a translate. I'm going to go to Utilities and Translate. And you got to think of it from the view we're working in. I'm going to go to my isometric view here, like so. So this is the top of the part. So from here, we're going to go down 1 inch. So all we're going to do is grab all of this geometry right here. Grab it. That one, that one, that one, and that one. And then we're going to drop it down in Z. We're just say -1. Make sure that you turn on the copies button. That's the most important thing here. And then we can hit OK and cancel out. So now what we're going to do is we're going to turn off the layers that we don't need. Now, even with a translate, the geometry that you translate, it doesn't go to the bottom layer. I just didn't want it in the same places where I'm working. So we're going to turn off everything that doesn't go all the way through the part. So for this one, it'll just be the slots and it'll just be the counter bore. All of that is going to just get extruded to 1 inch. So we'll go up to Create 3D. We'll do an extrude curve, and we're just going to drag a box over all of our geometry. Now, by default, it goes up 1 inch. That's just where it sets it up. But if we put a 0 in for the distance going up, and we hit tab or we click in another box, Bobcad will always enter a 1 into the other box. So if we zero this one out, the 1 goes back to the top. So I want to zero that out. There's my 1 inch down. I'll then hit OK and cancel out. So that has all the holes in it that we need it to have. So now we could turn our other layers back on. So there's our slots. There's our counter bore. Now, if we flip this part over, we'll see because we translated the stuff down, it also pops up on there when we do that. So now we're going to go in and just pick the top slots and cut them in 3/8 of an inch. So we'll go ahead and just say extrude cut. I'm going to click in the window. So this is big. For shortcuts to work, and you guys might run into this sometimes when you try and change just something as simple as your view. If the drawing window isn't your active, kind of the last click you made, some shortcuts don't work. So you need to make sure to just left click in this window and then hit the letter S on your keyboard. And that'll hide the shaded surfaces. And that allows you to then kind of get in there and grab that geometry. Because if that surface is there, Bobcad finds that surface. If you hide the surface, it grabs that line. So I'm just going to hold shift and pick all of these right here. Now, the distance that it's going up, I grabbed 2 of the wrong ones, didn't I? Yes, I did. That's the thing I was worried about doing. There we go. There and there. Did I do it with more than one? Yeah, I totally did. Did it with a bunch of them. All right, so there we go. So notice that it's going up 1 inch right now. We needed to go down 3/8 of an inch. But if we think about this now, we also need to do the same thing on the other side. But for the numbers here in Bobcad, they're going to be opposite. So the distance going up right now is irrelevant. It doesn't touch another solid model. It doesn't even touch the solid model we have. So it doesn't hurt anything if you do leave it up. So what I do when I'm doing a part like this where I got to go 3/8 deep is I set both the distances to 3/8. So now we're going up 0.375 and we're cutting into the part 0.375. Now, why is that important? Because when we do these bottom shapes, that 0.375 isn't going to be going down, it's going to be going up. So it just saves us a second. So go ahead and hit OK. And then if you want to hit the letter S on the keyboard, again, click in here and hit the letter S. There's the first set of cutouts. Then I'm going to make sure to pick the bottom ones this time, which I can actually hide the geometry for and drag a... I can't drag a box. Never mind, I can't drag a box. I'm just going to hold shift and pick all these. Just try to make sure I get the right ones. Putting them on a different layer wouldn't be a bad idea. We'll go ahead and hit OK. Cancel out. And now when we hit the letter S once again to turn it back on, we got those pockets getting cut in on both sides. And then finally, the last bit is just using the counter bore. And I would hide the slots. I would hide the base. And honestly, I would hide the bottom. But I've been putting my whole solid on the bottom. So I need to go to my select mode. I'm going to grab it. I'm going to pick the solid and then put my check mark on it. And I just want to use that modify to current layer. That way I can hide the solid. All right, so the last counter bore we have to do to make this thing a solid model is we're going to go ahead and do another extrude cut. The distance up is going to be 1/8 of an inch. The distance down is going to be 1/8 of an inch. That way I don't have to change those numbers again later on. And even with the layer hidden, just so you guys are aware, Bobcad doesn't care that the solid is on the layer. It cares about the fact that that solid that we're creating right now will intersect with that solid even though it's on another layer. If you wanted to add these two things together instead of subtracting, you'd do something like an extrude boss. We're going to subtract it, which is just an extrusion with a Boolean. So with our solid layer turned off, I'm just going to hit OK, pick the other piece of geometry, and hit OK. Now, like I said, even though it's on a hidden layer, it does still affect the part. So you can see there is There is the fully drawn part. Now, why would you ever go about doing this, especially after you've programmed the entire part? You wouldn't. You wouldn't. You would do this before you started programming, and it would make programming easier because now when I go to do my holes, all right, I'll do it as a new feature. I'll just go to my mill tap hole. Now when I go to do my holes, instead of picking just arcs, I can go and pick the surfaces, just like so, and hit OK. And then right there, it knows the diameter, it knows the depth. When we go to the next page, it knows where the top of feature is. Now, we would still have to account for the fact that there's the 100,000ths on the other side, like we talked about when we did this, but I didn't have to think about any of that. Having a solid model saves a lot of time. It's all you need. It's what you need when you're doing 3-axis, but for 2-axis, it is still very important. We're coming out with a new, we're calling it Launchpad. It's basically online courses for you guys to learn. And it's nice because you don't have to wait for anyone. You could do it at 2 o'clock in the morning if you wanted to. It's all going to be online. I'm working on 10 courses right now. And hopefully it'll be launching before the end of the year for sure. I'm hoping. We'll find out. But it goes through this. Now, it does have some 3-axis examples, but it's going to have about 5 2-axis examples where we go from drawing out the basic shape, drawing the shape, then turning it into a solid, and then machining it. Because though we don't need the solid, when it comes to machining the solid, it is so much faster to have a solid, It saves us a lot of time. Because one thing we could do now that we have a solid for like the pockets, the slots that we have, I can remove all the geometry and I could go and just pick the floors. I say, I want to machine all that right there. Knows the top, knows the depth, has all that figured out. I hit OK. We're going to get the exact same result here. But it's done. And all I had to do was click on some pockets. Where it really gets good is copy and pasting, because you can go in and just pick it. There's also, let me see if I have it. Let me grab the C-bore here. Or actually, which one? We did the center through hole. The center through hole we use the high-speed adaptive on. All right, so I know it's got an advanced pocket attached to it. So I'm going to copy that one, and I'm just going to go ahead and paste it. And now what I'm going to do with this, I want to use the same top, and no, I don't actually. So this is going to be the C-bore. Once again, let me rename this guy. 2. All right. So the geometry for this, I can go in and use this feature. It's called Detect Open Edges. So this is, if you guys have ever done open pocketing in the past, the way that you do open pocketing in BobCAD in the past was to use a dotted line. So if there was an area on your part that the tool was allowed to leave on, you would use a dotted line. But with this one, it reads these 2 chains. Let me get my top of part and my total depth, just like that, and I'll hit OK. Now I can compute that tool path, and we'll see what it comes out looking like. I'm pretty sure this should work. And there it is. So you have your pocket. Let me blank this. Oh, let me go back to my normal cam tray. I hate not having these buttons anymore. User interface, cam, classic, extended, right icons. Yes, apply. Okay. So now I could blank this out and look at, there is my pocket for that. So the normal counter bore was this spiral we have here. Let me just edit this real quick. What's our step over on this guy? 20% step over. This one is going much further. So let's go to 20%. And we'll just recompute that real quick. So we probably won't notice too much of a time savings here. But if we look, this counter bore is going to take 8.9 seconds and 8.7 seconds. It's not much when we're going, how fast are we moving right now? Let's see. So the pocket's going, let's say this is going 50 inches a minute. This will be a little bit better for us. We'll say 25 there. All right, so the pocket's going there. pocket's going to go 50 and, and 25. Apply. Yeah, okay. All right, so that's more like it. It's still only about a second. What's this toolpath even look like? Oh, yeah, okay, so that is it. So you'll notice with this one, and it's still really fast, but it's about 7 seconds worth of cutting because it's starting in the middle and it's spiraling out from there. If we look at this other one, which doesn't start, I mean, it still starts in the middle. It plunges in the middle, but then it feeds over. Whoops, that's the whole time. It's 1.9 seconds to 7 seconds. And that's because this second pocket that we're doing, why is this showing the whole time? Blank you out. Blank you out. The second pocket we're doing isn't cutting the inside. It's just going in and cutting that area. It detected the open pocket. It knows that that's an open edge without us having to go and extract the edges off the pocket or draw them out and then convert that wireframe piece of geometry. This, it'd be the base actually. We'd have to take that arc right there and make it a dotted line. And then it would know in the past, if you're using version 3.33, that's how you'll have to do it. That's how it knows that you're doing the open pocket. So detect open edges, it's a killer feature. You just pick the surfaces, but it all relies on you having those surfaces. But with that, you'd also be able to skip a lot of this stuff, like the feature mill hole that we did it, all in one. I could go in and do hole recognition. And not only could I do hole recognition, but when I created those holes, the way I should have created those holes was I should have used the advanced holes option when I did it, because then you can apply attributes to the holes. So the hole itself would be, when Bobcad reads it, knows that it is a threaded 1/4-20 hole. So there's a lot you could do with that. Play around with it. Like I said, we'll be releasing that new training stuff hopefully before the end of the year is my goal. And it'll walk through a few more examples of doing stuff like this, but you guys will be able to do them at your own time. So there we go. I didn't really plan much more than this. I thought this was going to take a little longer. But I'm here to answer questions. If you guys have any questions, let me know. I'll be here for a little while, probably at least a half hour, just waiting for you guys if you run into anything. If you didn't finish the part or you want a copy of this part file, let me know in the questions box. Just say I want it, and I will resend it to you. I'll save it right now. I'll do save as, just for those of you guys that have it. If you want it again, this will be end. Whoops, I'll do that in caps. There we go. End. And then save. So if anyone does want it, let me know. Otherwise, if you guys have any questions, put them in there. If you don't have any questions, have a good day. We're going to be back on Thursday, but it's for BobCam for SolidWorks, not Bobcad Cam. So it's our SolidWorks plugin that we have. But if you guys have it, join it. It's covering lathe. And then be on the lookout soon for some updates on this new Launchpad learning management system. It's going to be like online courses. You may have done some in the past. Pretty swift. So thanks, guys.